Hello everyone, and welcome to the Sodium launch event. My name is Alexis Smith, and I manage our Developer Partner Program here at the DFINITY Foundation. The DFINITY Foundation is a Swiss-based not-for-profit with a mission to build, promote, and maintain the Internet computer, and by doing so, improve the world. The Internet computer extends the functionality of the Internet from connecting billions of people to also providing millions of developers and entrepreneurs with a public compute platform, creating a revolutionary new way to build websites, enterprise systems, and internet services within an open environment. This public software development platform is created by independent data centers around the world, combining computing power using an advanced decentralized protocol called ICP, which allows software to run anywhere on the internet rather than on Amazon, Google, and Microsoft-controlled server farms. Big tech has distorted the way that we use the web, monopolizing wealth at the top and restricting innovation, entrepreneurship, and ownership of internet services. The vision of the Internet computer is to restore the ownership of the internet back to the people.
And I'm Michael Hunt, Director of Community. It's a pleasure to welcome you all to the Sodium launch event, right on the heels of the Tungsten launch event. During the Tungsten launch event, we opened up the Internet computer to third-party developers for the very first time. And since, we've witnessed entrepreneurs and teams build such a range of products. Things from massively multiplayer online games to pan-industry platforms combating counterfeit goods. Just 2 weeks ago, on September 17th, we held our first ever demo day, where 10 projects showcased their new solutions that were built on the Internet computer. You'll be hearing more about this in just a bit. Today, we are absolutely excited to recognize that the DFINITY team has reached the Sodium milestone, and we can't wait to show you all of the progress that has been made since the Tungsten milestone just earlier this year.
To put it in context, the DFINITY Foundation has not missed a single milestone on the Internet computer's public release schedule. Our roadmap began at the Copper launch at San Francisco Blockchain Week in November of 2019, where we released the DFINITY Canister SDK and the Motoko programming language. Then, in January of 2020, we announced our Bronze milestone at the World Economic Forum in Davos, where we showed an open version of a professional social network called Linked Up, running in the browser, which we deployed to an independent data center in Switzerland. Shortly thereafter, we began working toward Tungsten, where our goal was to create a network of multiple data centers to which third-party developers could deploy infinitely scalable apps. We also previewed an open, scalable video sharing app called CanCan on mobile. Each of these prior releases can be seen as phases of rebuilding earlier eras of computing in a decentralized form. Copper was terminal-based, Bronze with desktop web, and finally, mobile with Tungsten. Sodium, the fourth of 5 milestones, represents the future of computing, as we introduce the open algorithmic governance system that will manage the network. The Sodium milestone is also noteworthy because it's the last milestone before the public launch of the Internet computer at the end of 2020.
During the Sodium launch event, you will hear from our founder and chief scientist, Dominic Williams, to learn about the network nervous system and the tokenomics behind the Internet computer. You'll also hear from members of DFINITY's research and engineering team on the groundbreaking advanced cryptography and computer science they've been working on. We'll hear from leading industry experts such as Jake Brookman, founder of CoinFund, and Wilson Withiam, research analyst over at Masari. We'll also learn about the extraordinary impact of the Internet computer firsthand through Origin, a luxury goods marketplace. We'll also get some really special announcements from CoinList and Polychain Capital. Finally, we'll have a live AMA at the end of the show with our founder, Dominic Williams, so please be sure to drop your questions in the hop-in chat along the way.
So, without further ado, I'd like to turn it over to our very own founder and chief scientist, Dominic Williams, to provide us with a few opening remarks. Take it away, Dom.
Hello everyone. Welcome to the DFINITY Foundation's Sodium Milestone launch event. Thank you for joining us again. This is a big one. Sodium is the final milestone before Mercury, when the public internet computer comes into being later this year. When we next come together for another event, early 2021, today's Sodium network will already have been upgraded for the last time. Mercury will have passed, and the public internet computer will be running on specialized node hardware operated by independent data centers worldwide, and a new era will have begun. I'd like to let you know that there are already hundreds of nodes running. With this event, we crossed the Rubicon. But how do we get here? How do we create new cryptography and protocols, a new environment for a new software? How do we develop Motoko, an important new programming language, and also release SDKs for other languages such as Rust? How do we create a community of data centers? How do we reach out to universities who will teach Motoko and internet computer courses? Bringing the project to this moment has involved relentless human effort, determination, innovation, and sheer willpower, and we all owe an enormous debt of gratitude to those working tirelessly behind the scenes. There have been many bumps in the road, twists and turns, and many skeptics claimed the Internet Computer Project, which reimagines not just what's possible in blockchain, but also the very nature of software and IT, and how we will build the websites, enterprise systems, internet services, DeFi, and dapps of the future, as somehow impossible, or that the project would fade out. In fact, the opposite has happened. DFINITY never deviated from its original plan and kept on doubling down. We built a machine to build the impossible machine, an organization spread across multiple international research centers and remote teams with the specialized science and engineering skills necessary to take on the Internet Computer Challenge. That organization is still growing and adding more talent every day, which is incorporated into the carefully designed research and engineering processes that have already taken us this far. And this is the fourth public milestone which we have hit on target, and it is also the last before the public internet computer comes into being. Now, with the support of DFINITY Developer Outreach, a small army of external teams has begun building for the internet computer. This event has lots of reveals about what is happening. Enjoy and stay tuned. Thank you again.
I'm Liz Yang, a go-to-market program manager here at DFINITY. With the release of the Tungsten Developer Network on June 30th, we welcome third-party developers to begin building on the internet computer. Since then, we've been nothing but delighted and impressed by the creativity and ingenuity of early adopters building on the new internet. To highlight the top 10 teams building on the internet computer, as well as provide direct support to these fledgling teams, we organized a developer showcase called the Tungsten Demo Day, which happened earlier this month. We had teams from all over the world apply to be a part of the Tungsten Demo Day, and excitingly enough, we had a really wide range of applications ranging from decentralized financial services to social impact initiatives, as well as even software for producing music. The Tungsten Demo Day culminated in a tie between two co-winners, Sailfish and Get Impact Now. First up, from Thailand and the United States, we have Sailfish, a decentralized exchange with a social component. Team members include Norton Wang and Teddy Nee. Let's take a look to see what they've been working on.
Sailfish is the first decentralized exchange on the DFINITY Internet Computer with token swaps, borrowing and lending, and social features like chat and forums. To bring assets onto DFINITY, we can build bridges. So here we have an example of a ETH to DFN bridge. I'm going to go ahead and swap 0.01 Kovan testnet ETH into DFN ETH, which is just a representation of Ethereum on DFINITY. So once this transaction confirms, we'll see our new DFN ETH balance increase by 0.01. Cool. Once we have this token on DFINITY, we can go ahead and trade it for other DFINITY assets. So let's look at this pair right here. So this is the liquidity pool that contains both ICPT, which is the native DFINITY governance token, and DFN ETH. We're just doing some simple automated market making here to offer pricing and to provide liquidity. Looking at the ICPT page, we can go ahead and make a trade of our 0.01 DFN ETH for about 0.18 ICPT. This transaction is happening inside the DFINITY Canister, going through our automated market making system. So once this confirms, hooray, we have a new balance of 0.18 ICPT.
Thanks again to Sailfish. It's so exciting to see the interoperability and composability of DeFi on the internet computer. Next up from Germany, we have Get Impact Now, a platform to increase political and civic engagement. Team members include Philipp Litzenberger, Bastian Schäfer, Phil Lichtenberg, Arno Rinke, and Tobias Meyer. Let's take a glimpse at what the team has been working on.
All right, welcome to my Get Impact Now home screen. I'm Alice, and here you can see my circles of impact. So these are the geographical levels where I can get involved in political issues or societal matters. Let's dive straight in and have a look at my district, St. Georg. You can see here I've currently got 12 issues pending, so those are the issues that I'm actively debating in. 2 here in yellow are actually in favour and 1 is opposed. And by that filled bar you can see how far along the discussion is on this topic. If we click on to engage, you can see the 3 topics here that I'm currently quite interested in, particularly the green cycle road I'm quite passionate about because I do love riding my bike and it's something that I'd really like for my neighbourhood. If you click onto this, you can gain some more background information on this debate topic and you can watch this neat video to get some more details. You can then leave your opinion and also read other neighbours' opinion and arguments for or against this green cycle road. So personally, I've actually seen this in some of my friends' home cities and I can connect with them to also find out what they've done to make it happen and realise this project. I hope you enjoyed this brief overview and thank you very much.
Congratulations again to the co-winners of the Tungsten Demo Day, Sailfish and Get Impact Now. These 2 projects are just a glimpse of the entrepreneurship taking shape on the internet computer and really just the tip of the iceberg. As we approach public launch, we look forward to shining a spotlight on other developer projects to come.
Hi, I'm Jake Brookman, founder and CEO of CoinFund. As investors in the blockchain technology space, we seek decentralization products that are highly competitive with traditional and incumbent products. I've identified 9 core value propositions of crypto networks, which I'll talk about in this talk. If you're building on DFINITY, keep these core value propositions in mind and integrate them into your products early, because these are the things that are really going to differentiate your product against Web 2 and everything else in traditional world. So the first core value proposition I want to talk about in crypto networks is permissionlessness and the censorship resistance that comes with it. Blockchains can enable networks that are resistant to centralized control and censorship. The value proposition of permissionlessness is a combination of being open, as in having an open API that anyone can use, as well as maintaining open source code, together with strong, verifiable guarantees about that API. One example of a strong guarantee is immutability. Oh, like this API can never change. Another is transparency. This API can change, but only transparently by way of public governance in the network. Open permissionless crypto networks compete with centralized incumbents who use their monopoly power to skew open markets and co-opt the platforms upon which commerce is progressing, often disadvantaging their own customers. Examples include Amazon using platform data to compete with its own merchants on its own platform, or Twitter disrupting third-party businesses by modifying its public APIs to suit their own interests. Censorship resistance and permissionlessness allows a high degree of composability of technologies. Third parties can come along and feel very comfortable building on APIs that either never change or change in very predictable ways. The second core value proposition that I want to talk about is borderlessness and the global access enabled by blockchains. Using the value proposition of borderlessness, crypto networks are advancing the notion of the internet as its own cross-jurisdictional commercial zone. Blockchain technologies have opened up new cross-border markets by making transactional commerce more efficient and viable. Unlike communication and financial technologies of the past, these networks are an internet technology that are not inherently bound by political borders. The technology simply works across the network of globally connected smartphones, computers, and devices. Borderless technology is harder to achieve as a centralized organization, beholden to hundreds of countries and legal jurisdictions. But unhindered by borders, crypto networks act as a global technological substrate upon which local commerce is executed, with jurisdictional concerns delegated to the edges, to the jurisdictions themselves. Public governance and governance as software is the third core value proposition I want to talk about today. Blockchain technology enables public governance of capital, resources, and organizations in a way that has never been possible before. Namely, it ushered in an era of governance as software, creating inclusive, transparent, and digital governance systems that manage millions of dollars in real value. This is not a prospective technology. Public governance of crypto networks is in the market today. Applications built on top, such as decentralized marketplaces, are beginning to take the role of public or common goods. We're used to such goods being regulated by governance, but now a new model of direct public governance by users is possible, and that has never really happened before in a meaningful, scaled way. Most interestingly, crypto networks are well suited to deliver the technology of governance in the form of secure voting and decision-making systems. They open up a whole new era in the theory and practice of governance systems themselves. Today, this field is growing rapidly with decentralized autonomous organizations. And honestly, if you think about it, as humans, we've only had like a couple of thousand years of experience with governance technology in the form of governments, in the form of public governance. But never before have we been able to modify governance systems on a 2-week software development cycle, just like we do with software. This is a highly disruptive property of crypto networks. Political decentralization and regulatory arbitrage are the fourth disruptive core value proposition of crypto networks. Political decentralization refers to the ultimate owners of network hardware, software, and assets. When we say that Bitcoin is not owned by any one person, organization, or government, we're referring to the distributed ownership of the network, which is shared among its public participants, the developers, the miners, and the users. Cooperatives and consortiums are the traditional example of political decentralization. But blockchain networks take this kind of decentralization to the extreme, allowing individuals or even devices or AIs to be direct stakeholders and beneficiaries. One of the most disruptive aspects of political decentralization is that it creates large-scale regulatory arbitrage. Regulators, often concerned with ensuring the legal compliance of corporate entities, must now adapt to systems which are digitally native, have distributed public ownership, and can operate by strong programmatic rules. Capture resistance is the fifth core value proposition of crypto networks. Crypto networks are a coordination technology that can create safeguards and strong recourse for those times when a particular group of participants becomes too powerful and begins to exercise tyranny or suboptimal network governance. Just like in software, decentralized networks can be forked or split off by subsets of participants who disagree with a network's way of doing things. The open market can then decide which version of the network is more suitable, or they can coexist for the sake of consumer choice. Contentious forking is a capture resistance mechanism for those times when participants cannot agree on a common set of rules or parameters for the network, and the two groups must part ways. The sixth core value proposition is mutualization and secondary markets. Wikipedia defines mutualization as, quote, the process by which a joint stock company changes legal form to a mutual organization or a cooperative so that the majority of the stock is owned by employees or customers. It is just a certain way of taking a company public. And that's what crypto networks have been doing so much more effectively than traditional companies. Most crypto networks are inherently mutualized by virtue of having native digital assets that represent public ownership by participants. In contrast, many corporations that provide modern public infrastructure tend to be managed by executives who act in their own self-interest, creating the potentiality of agency problems or corruption. So why is mutualization an important aspect of blockchains? Mutualization enables individuals to truly own, not just use, goods and resources. Privacy and security is becoming more and more of a competitive vector that crypto networks have against traditional companies and incumbents. And this is the number 7 core value proposition. Unlike many centralized legacy applications, crypto networks place a strong emphasis on cryptographic primitives and their security. As public systems containing billions in value, crypto networks undergo a process of continuous compromise resistance and security upgrading. Core value proposition number 8, trustlessness, outcome certainty. Crypto networks, and especially smart contract platforms, create an economic substrate, an operating system for commerce where parties can do business and also significantly reduce their transactional risks. Transparency, verifiability, and automation of transactions all play into the trustlessness of blockchains, and few legacy systems can provide such guarantees today or have any incentive to do so whatsoever. The core value proposition of Ethereum and similar platforms is to enable cryptographic guarantees that economic transactions can proceed with a high certainty about the outcomes. This is an efficiency mode that reclaims massive value otherwise lost to counterparty risk, intermediaries, and dispute resolution. This is a game changer for commerce. And finally, the last but not least core value proposition, number 9, and the most important one, arguably, is cryptoeconomics and recursive incentives. The ability to design financial incentive mechanisms using smart contracts and digital assets, generally known as cryptoeconomics, is the most disruptive value proposition enabled by blockchain technology as a whole. Based on the game theoretical study of mechanism design, cryptoeconomics puts into practice the construction of incentive mechanisms for economically rational actors. Cryptoeconomic mechanisms include proof-of-stake systems, decentralized exchanges, smart contract auctions, token distributions, hardware and software mining, decentralized oracles, and so much more. The design space of such mechanisms is bewilderingly large, and the cost of implementation is incredibly cheap. A particularly interesting paradigm within cryptoeconomics is that of recursive incentives, wherein a token is used as a placeholder for future cash flows generated in a crypto network. As early network participants trade the token speculatively, they create the network capital used to actually generate the fundamental value of the network. In essence, recursive incentives help networks finance themselves, exploring new paradigms for capital formation and creating new investment opportunities for individuals. That's what we look for at CoinFund when we think about highly disruptive blockchain decentralization technology. We look for networks that are implemented on permissionless, borderless blockchains that enable a high degree of decentralization, privacy, and security for its customers. Those are the 9 core value propositions of crypto networks, at least from our point of view as investors. If you're building on DFINITY today, we got a lot of work to do, but if you keep these value propositions in mind, I think that the products that we'll end up building will be very disruptive to traditional technology. I wish everyone the best of luck with whatever they're building.
My name is Wilson Withiam. I'm a research analyst at Messari. I spend most of my time studying, researching, analyzing base layer platforms like Ethereum and DFINITY's internet computer. For those that don't know Messari, we're a data aggregation site. So you can go and check out any of the best prices on assets and what you want, but we also have a lot of other tools associated with that, including charts and screeners where you can get all the other data points beyond just price. We also have a large number of educational materials around these assets as well. So you can come and learn about them, explore them. And then we have a research team, which includes myself, that dedicates our time to developing a lot of in-depth research on a lot of these different projects and assets. So right now, DeFi and Ethereum is booming. The sector has pretty much kind of launched us into what could be the next market growth cycle. And what I want to talk about is that with this tremendous amount of activity that's happening, while invigorating, can potentially come at some costs. And in this case, the cost can be gas costs or transaction fees. So anyone that has tried to use Ethereum recently, trying to submit a transaction may not be the most financially feasible thing to do. So as these users really start to encounter high fees on Ethereum, what could this mean for other base layer platforms? Could we start to see some growth somewhere else, applications going elsewhere, users going elsewhere? There's definitely a potential for that, as well as maybe some collaborative efforts between Ethereum and some other networks. So to kind of backtrack a little bit, how did this frenzy around DeFi kind of pop up? The movement around DeFi really isn't anything new. There's been development in the space for years, and the motivation behind it kind of underpins the whole ethos behind the crypto industry. So over the past few years, we've seen a lot of development on these applications that really are starting to offer real value, such as the ability to acquire and transact in stable value or stable coins, or the ability to use non-custodial exchanges or lending platforms. And a lot of these applications have kind of opened the door for some long promised features of blockchains and crypto, including token-weighted governance. So there were some components that led to the rise of DeFi along the way. One in particular was the idea of smart contract composability, which is really the ability to build new applications using components from existing ones. This sped up the rate of software development, and that's why you've seen a mass explosion of applications in the DeFi space, because you're able to use these existing primitives as opposed to building something from the ground up, which takes time, which is time and resource intensive. That really isn't possible without these open permissionless standards that we have around not only tokens but also our smart contract code. The other one was liquidity mining, which is really just an incentive form to bring users onto your platform. You essentially give out new tokens to users that lock up value either on your exchange or in your lending platform. And it benefits the project because they need users on board. They need more capital on board to provide enough liquidity to other users. And at the same time, it allows users to actually earn more in return for what they're providing to the platform. So it was this new token distribution mechanism, or maybe not new, but this recent DeFi, rise in DeFi popularized the use of liquidity mining. And that's why you're starting to see all these different vegetable themed forks pop up, because of the ability to just hand out a new token, say, hey, you can earn this massive percentage of yield, and maybe it might be useful later on. So like 2017, you start to see some projects pop up that may not have the best intentions, but it's decidedly different this time around because you actually have people using the platforms for what they're intended, as opposed to just holding a token hoping it appreciates down the road. And I say this in comparison to what we've seen in the 2017 ICO boom, where you had this mass explosion, this Cambrian explosion of tokens that really ended up being valueless. Payment tokens added more friction to many of the applications that were created during that time. However, this time around it's decidedly different. The DeFi movement was supported by real projects that provide actual solutions. And in most cases, they have users that are actually using the platform for its intended use case, as opposed to just token holders sitting and waiting for the token to appreciate. Also, you kind of have more tokens this time around that actually have some sort of utility in the ability to potentially accrue some value, most in the form of a claim on trading fees or lending fees. What you're also seeing right now is the current infrastructure is far more robust than it was a couple of years ago. And this is very apparent in the way decentralized exchanges work now compared to what they did. The current prevalence and liquidity that exchanges like Uniswap have were almost unfathomable back in 2017. And now you're starting to see DEXs win the battle of listing long tail assets, and they're starting to actually encroach on the trading volumes that you see on traditional centralized exchanges like Coinbase. In addition to this growth in infrastructure, you're also starting to see an infiltration of stablecoins, which has enabled users to limit their exposure to volatility. And this has also helped the DeFi industry grow as it's onboarded new users who may have previously not have wanted to get involved because of the volatility. With Ethereum's fees rising, it could tend to price out some users and even turns DeFi into what could be a game for the wealthy few. This would in turn lead users and maybe other applications to start to explore other networks that are offering better transaction fees. Solutions can be some layer 2 infrastructure that's being built on Ethereum right now. The alternative is looking at other blockchain networks with their own DeFi ecosystems building up. And many of these networks, either because they're new or they have a different fee structure, may offer lower fees in general, and in turn can make a more profitable opportunity for some users. And in an industry starved for yield, many of these users will be more than happy to migrate over to another platform given a sufficient level of options and an easy onboarding. Alternative networks, including DFINITY's internet computer, stand to benefit from activity leaking out of Ethereum. But it's worth noting that you'll see the exodus of users and applications will end up pitting some of these greener platforms against each other. There are some key components to attracting and keeping users and developers. And some of these include robust tooling and composability standards, as we covered earlier, which led to some of the growth of DeFi on Ethereum. The rest and how like keeping users from there will particularly depend on what applications are built and the ease of onboarding new users onto the platform. However, there's an often overlooked aspect of what could be this smart contract or base layer platform race. We often overlook the cross-chain synergies that could pop up along the way. It's very possible that the platform wars are not a zero-sum game. In some ways, platforms that offer differentiated services or technological components can complement existing networks. For instance, Ethereum-based DeFi applications can host their front ends on the internet computer as opposed to AWS. And I know this is something that has been top of mind from the DFINITY team, as illustrated in some of Dominic Williams' recent blog posts. When the market gets hot, new opportunity arrives, and this attracts new users, new developers, community members that are really going to help grow the crypto industry from here. And that's really the goal. We want to grow the entire industry, and it's going to require an influx of new people in every one of these market cycles. So that's what these cycles really do. They bring in new people when there's opportunity, and then we don't know where the market's going to go from here. It could continue to flourish like it has over the last few months. We could see a bit of a cool down, not too sure, but it's during that time where you're going to start to see a lot many more ideas, pieces of infrastructure get built up that can really kind of help the next stage of applications develop. Whereas token sales were fleeting, DeFi has staying power, and it will likely be the sector that sparks the exploration of networks outside of Ethereum.
Hello everyone again. In this session, we're going to talk about the tokenomics of the internet computer, which are appearing in the Sodium network. The token everyone is talking about is ICP, which was previously called DFN. ICP is primarily a governance token that can be used in the management of the blockchain network created by the Internet Computer Protocol, which is where the letters come from. When the network launches, there will be just over 469 million of these tokens in existence. They are distributed among 4 main cohorts. The first cohort is 500 plus financial contributors, which are made up of those participating in the February 2017 seed round and the later 2018 strategic and pre-sale fundraisers. The pre-sale price, summer 2018, was 4 Swiss francs and 17 cents, or about $4.50. Of course, many things have moved forward since 2018. The second cohort is the 150 plus team contributors, made up of the 120 current full-time team members and others who have contributed over time. The third is 50,000 plus Airdrop participants who participated in the airdrop we ran in 2018 and successfully passed KYC. And finally, there's the DFINITY Foundation itself, which holds tokens in an endowment that it uses to fund operations. But what role do ICP tokens play within the broader token ecosystem on the internet computer, and how might they be used? The internet computer actually has 2 native tokens, ICP and also cycles, which are used as fuel for computation. Additionally, every canister can create its own token if it wishes, which shares its identity. A canister can hold balances of any token and can send tokens to other canisters as part of function calls. On the internet computer, tokens can be used for anything, from loyalty rewards through payments, the securitization of assets, and the governance of open internet services. Let's look at how ICP tokens, in particular, can be used in more detail. You can do 2 things with ICP tokens. Firstly, by locking them inside the network nervous system, the algorithmic in-protocol governance system that manages the network, you can create neurons, which can vote on proposals and earn voting rewards, also paid in ICP. Secondly, you can transform ICP tokens into cycles, a kind of stablecoin used as fuel for computation by canisters. When you create a neuron, its voting power, and the rewards you receive from the network nervous system when your neuron votes, start off by being proportional to the number of ICP tokens you locked inside. So for example, all things being equal, a neuron that locks up 200 tokens will have twice the voting power and receive twice the rewards for voting as a neuron that locks up 100 tokens. Depending on your neuron's configuration, a maximum voting reward is available each month. The network nervous system tracks the proportion of votes your neuron participates in and pays you a pro rata share of that maximum reward. Luckily, you can configure your neuron to mostly vote automatically by following other neurons you trust, so it's possible to receive the maximum available reward without doing too much work. Some other factors affect your neuron's voting power too, and the rewards you receive. A neuron behaves a bit like a time deposit bank account, where you can ask to withdraw your money at any time, but it is always given to you after a delay. Essentially, to withdraw ICP tokens locked inside one of your neurons, you must dissolve it. Dissolving takes time, but you can start and stop the process of dissolving a neuron whenever you like. The minimum time remaining before a neuron can completely dissolve and release its locked tokens is known as the dissolve delay, and this falls while a neuron is being dissolved. The dissolve delay is configurable by a dial in your neuron's online management interface. The longer the dissolve delay you set, the greater your neuron's voting power and the greater the voting rewards you will receive, because this encourages you to vote with a longer-term view on driving the success of the network. You can increase the dissolve delay anytime you like. However, the dissolve delay can only be reduced by putting the neuron into dissolve mode. You can think of this being similar to a kitchen timer, where the dial can be twisted clockwise to increase the countdown, but the countdown can only occur through the passage of time. In order for your neuron to participate in voting, the current dissolve delay must be set at between 6 months and 8 years. Personally, I plan to twist all my dissolve dials right the way around to 8 years to maximize my voting power and rewards, as this is a long-term project. The final way neurons increase their voting power and voting rewards is by growing older. The age of a neuron is the time that has elapsed since it was last placed in dissolve mode. Financial contributors to the Internet Computer Project will receive their ICP tokens locked in neurons that have a generous pre-existing age, and will be able to choose between quickly dissolving their neurons to obtain their ICP tokens or configuring longer dissolve periods so they can participate in voting and earn rewards. The network nervous system's payment of voting rewards to neuron holders is inflationary. But let's look at the other way ICP tokens can be used. The other use for ICP tokens is that you can convert them into cycles. The conversion of ICP tokens to cycles occurs at a variable rate, which is constantly configured by the network nervous system in response to external markets, such that burning approximately 1 Swiss francs worth of ICP, which is about the same as $1, will always create 1 trillion cycles, which we refer to as a T. Software canisters that live on the Internet Computer blockchain must be charged with cycles, which are used to power computations and memory management and are burned in the process. Over time, more and more cycles will be burned by computation. Since cycles can only be created from ICP tokens, effectively over time, more and more ICP tokens will be burned by computation and disappear. This guarantees that so long as computations are running on the Internet Computer, someone somewhere must be buying ICP tokens as a means to create the cycles that power them. When ICP tokens are converted into cycles and burned by computation, that's deflationary, as it reduces the supply. The value of cycles will stay approximately constant, which ensures that the cost of computation remains stable and predictable and allows them to be used as a store of value, for example, within DeFi applications. The value of cycles stays stable for 2 reasons. Firstly, the network nervous system creates a firm ceiling on their price because it will always create 1 trillion in exchange for approximately 1 Swiss francs worth of ICP. Secondly, if there is ever a surplus of cycles on financial exchanges, say, and the price there falls, users will then purchase those cheaper surplus cycles for use as fuel, leading to them all eventually being burned by computation, such that future cycles will have to be created by converting ICP, which returns the price to its usual ceiling. The Internet Computer's use of computation to produce a stable value for cycles is potentially revolutionary. Holders of cycle tokens receive a guarantee that, so long as the internet computer is running, eventually all surplus cycles will be burned and the value of their cycles will return to its usual peg. This works in stark contrast to the stablecoins of today, where such tokens are either collateralized by assets held in trust by custodians acting as issuers and redeemers, or their values are stabilized using elaborate schemes that depend on assumptions about the volatility of crypto assets held as collateral, which in both cases makes them difficult to trust. The power of cycles underscores that the internet computer stands ready to facilitate DeFi just as much as it will help developers create the hyperscale internet services of tomorrow. The last thing I want to mention is open internet services and their governance tokens. We hope open internet services will eventually provide alternatives right the way across today's closed, monopolistic, big tech ecosystem, and we will see open versions of services such as YouTube, LinkedIn, Salesforce, and Facebook. That is why we are developing Linked Up and CanCan, LinkedIn and TikTok clones respectively, as sample apps. Open internet services will be built from autonomous code that is controlled and managed by open tokenized governance systems, which function similarly to the network nervous system. Tokenized governance systems for open internet services are coming soon and will generate their own token, which is to be used in voting and could potentially receive a distribution of value created by the autonomous system. What's exciting is that each governance system shall contain its own decentralized financial exchange, where their governance token can be traded for cycles. With this financing mechanism, we hope that talented teams of developers and entrepreneurs all around the world will find ways of extending the fabric of the internet by creating a new breed of open internet services. Thanks again, and bye for now.
I'm Enzo Hausecker, an engineer on the SDK team at DFINITY. Folks have heard a lot about the internet computer's recent introduction of token economics, but probably still have questions like, what are cycles, why do I need them, how do I get them, and how do I use them? So to remind everyone, cycles are tokens that developers use to pay for the computation and storage they consume on the internet computer. From a developer's standpoint, their computation and storage requirements are defined in WebAssembly. That WebAssembly can be bundled into an interoperable compute unit called a Canister and uploaded to the internet computer. Because every canister consumes at least some resources, canisters must be periodically charged up with cycles to maintain operation. Today, we introduce the concept of a wallet canister to help developers manage this flow. Not to be confused with a wallet to manage one's private key, wallet canisters build on the low-level system API provided by the internet computer's WebAssembly-based virtual machine. In practice, they are just a thin layer of abstraction around this API, but the end-user experience amounts to a fully managed data store for cycles and other tokens. With a wallet canister, you can easily view balances of cycles and other tokens, send cycles and other tokens to other wallet canisters, view recent transaction history, manage custodianship, and forward arbitrary calls to other canisters carrying cycles or other tokens in a message payload. Let's see what this looks like in practice. Now, I've already installed the latest version of the Internet Computer SDK. We can verify that with the fx-version. And I've made 2 applications for access to Sodium on behalf of the fictitious developers Alice and Bob. The application process has completed, and both Alice and Bob have become controllers of their respective wallet canisters. I've taken note of the canister identifiers provided in their onboarding emails and aliased them accordingly. Let's query their cycle balances to see how many they have. So Alice has got, looks like just over 5 trillion cycles, and Bob's got about the same. Now, cycles function like a stablecoin. So 1 trillion cycles is about 1 Swiss franc. So both Alice and Bob have just over 5 Swiss francs. Let's go ahead and transfer 1 trillion cycles from Alice to Bob. First, let's just remind ourselves of the canister identifier associated with Bob's wallet. And now we can invoke the send cycles method. Which takes 2 arguments. The canister identifier of the wallet to receive the funds, so that's Bob. And the number of cycles that we want to transfer here, and we said that that's going to be 1 trillion. So now that that's completed, let's go ahead and query the cycle balances one more time to just see how many they have. So we see Alice has got like 1 trillion less, and Bob has got 1 trillion more, of course, minus a small number of cycles that were consumed by performing this transaction. Now, you may be like me and prefer to do much of this from the command line, but you don't need to. User interfaces can be deployed alongside wallet canisters to provide much more interactive user experiences. Using WebAuthn security, we can register hardware authenticators, such as the YubiKey I've got here with me, that will allow you to sign transactions from a web browser in the same way as DFX. To start here, just click Generate Registration and touch your device to activate it. Now, I create a device alias as prompted here. Let's just say YubiKey. And copy this command and let Alice run it in her terminal. And now, just going back, just click on Connect Device, and as the owner of the YubiKey, I'm now authorized as a custodian. I can send transactions from Alice's wallet, or simply view transaction history. Here, for example, is the 1 trillion cycles that Alice just sent to Bob. Now, the internet computer uses a canister pay model. This is very different from a user pay model. It means that by default, and unless otherwise caught by built-in denial of service mitigation techniques, when a user sends a message to a canister, the canister who receives that message pays for all the computation and storage associated with it. And the user is not expected to include cycles or other tokens in the message payload. This provides for a much better user experience because it means that canisters can do things like serve user interfaces directly into your web browser without having to install weird browser extensions. But as you can imagine, there are use cases in which you may want to include cycles or other tokens in the message payload. Wallet Canisters introduces concept of call forwarding to handle this. Now I have a third canister here, written in Rust. This is not a wallet canister, but it does expose a method called cycle balance. Additionally, it has a method called hello that simply replies with the string hello. This is basically just a hello world canister, but with one unique exception. This hello method will go ahead and extract cycles out of a message payload that is sent to it, and it will keep those cycles for itself. Now we can call this hello canister directly with DFX canister call, and then just give it the ID of that canister and the method that we want to invoke, which is hello. We see here that it returns the string hello. This is just a standard call, so there is no cycles included in the message payload there. And we can also invoke that cycle balance method as well. So we see here that this canister currently has a cycle balance of, looks like just over 88 billion cycles. Now using call forwarding, I'm going to invoke that hello method again, but I'm going to include with it some cycles in the message payload that hello method will keep for itself, will keep for that canister. So first I'm going to, again, using call forwarding, call Alice's canister and then have Alice's canister call hello. So the syntax there is DFX canister call, and then we'll call Alice's wallet. And we'll invoke the call forwarding method, which is called call. And it takes 4 arguments here. which is the identifier of the canister that we want to call, the method that we want to invoke, any arguments, there are none actually in this case, and the number of cycles that we want to include in the message payload. So that's going to be 1 trillion. Let's include 1 trillion cycles in the message payload. Now the reply here is just a raw byte sequence. This is actually by design. You may recognize the trailing 5 bytes here though as the string hello. So it's just the response is actually just encoded here. But the forwarded call has actually returned here as expected. And if I go back and query the cycle balance for that hello canister, you'll see it's increased by 1 trillion. So it looks like we've got 1,088 billion and change. So yeah, right there with call forwarding, your wallet canisters can become your entry point into the system for a wide variety of use cases. So there you have it. Wallet canisters let you view balances of cycles and other tokens, send cycles and other tokens to other wallet canisters, view recent transaction history, manage custodianship, and forward arbitrary calls to other canisters carrying cycles or other tokens in a message payload. Thanks so much for watching, and I hope to see you on the Sodium network.
So Sasha, pleased to connect about Big Map and Big Search. Sasha is working on a library that will enable developers to create dapps that scale out without bound. And he's been working with the CanCan team to enable the CanCan sample app to store vast amounts of user video and to make all that content searchable. And this really is completely revolutionary, of course, because no one could ever have imagined a few years ago that it would be possible to store this kind of data actually on a blockchain and be able to stream it to users. So this is a work in progress, but developers working with Sodium can already access Big Map and Big Search where it's at and make use of it in their own projects. Although we hope to get the whole thing ready for prime time by Mercury. Sasha, would you like to tell everyone some more about Big Map and Big Search?
So for Tungsten, previous quarter, we demonstrated CanCan, and CanCan used Big Map, as you said. However, Big Map was very tailor-made for CanCan, and now we wanted to make it a bit more generic to allow other internet computer applications to use it. And in anticipation for this, we made a number of improvements for Big Map. For example, we wanted to make it more in line with what developers would expect from a regular cloud object storage, such as Amazon S3. For instance, we have now functions get, put, which are standard. Then we have append to objects, delete, list, and status, and some other operations that are specific to the internet computer. This allows developers to have more smooth experience when they start developing on the internet computer. We also allow with Big Map users to scale their applications anywhere from a single canister to millions of canisters and to exabytes of data, essentially. And we also, on top of all of that, we added the functionality for full text search in Big Map.
That's really exciting. Do you want to demonstrate some Big Map operations?
So here on my screen, on the left side, you can see Web UI, which we created as a user-friendly way to interact with Big Map. It shows that currently Big Map is running in a good state. It has 8 data bucket canisters, which don't have any data essentially right now. So that is the main overview menu, and then there is another menu which provides some details on Big Map, such as usage over time or distribution of data across canisters. And finally, there is a search part for full text search. And on the right side, there is a CLI where developer can interact and perform maintenance operations, so administrative actions, and at the same time get experience with working with Big Map. For example, we have CLI operation, which is called get. As I said, Big Map is now empty. So when we get this new key, Big Map tells us the key doesn't exist, right? So that is fully expected. So let's add this key with some value. We just say new value over there. So this will go through the Big Map and insert this new value. And now if we do get new value, it instantly pops back and says, here's the value that you asked for. So lookups are much faster than inserts, as expected.
Because an insert is using an update call, which has to be replicated across all the nodes in a subnet. But a query call, of course, is executed a bit differently.
Yes, exactly. So that is much faster, right? So one other thing that we support is appending to objects. So getting an object can be done in a much more efficient way. So we can get much bigger objects than we can insert. So insert is expected to be done in batches, right? In increments. And one thing,
and I suppose append is useful if somebody's uploading video as a stream or something like that.
Exactly. So in this case, we created an empty 500 kilobytes file, so half a megabyte. And now we're just gonna append that file, or actually we could put it, but let's just append it to an object called large video object. So this is gonna create a large video object in Big Map and write 500 kilobytes of zeros in there. It could be any video content, right? This is just binary data.
Of course.
And then we can repeat that again. On the left side, you can see that the dashboard increased the total utilization to 512 kilobytes, which is, again, as expected. And now append finished, the dashboard is gonna get updated to 1 megabyte utilization. And if we get the object to a local file, we can see that the append was just completed. We have a 1 megabyte object that we just wrote in 2 chunks of 512 kilobytes. And if we check the data that is in there, it's all zeros as expected, right? And if we do a list on Big Map, we see that there is just a new key that we just inserted in a large video object as zeros. And we can do a delete of a large video object over there. And this will free up space in Big Map in case someone decides that some object is not needed anymore.
That's very cool. I mean, I think for many people coming from a traditional blockchain background, it'll seem almost impossible that you could have just written that much data to the blockchain, effectively to smart contracts, and now it resides on chain. Indeed. This is something that someone would expect from a cloud storage, not exactly from a blockchain. Yeah. Now with these advances in the internet computer, the blockchain is becoming the cloud. And this is a really fundamentally revolutionary step. It can change everything. So I know this is early. I know you're interacting with the Big Map on Sodium from a single computer terminal, but could you upload a bit more data to Big Map to show off how it works? Sure, absolutely. So right now we have 8 data buckets. We just uploaded some data into it. We see that 2 data buckets are actually used, nothing else is. And now we can start some seeding of the data, some random data to these data buckets. So this function will create 500 keys, each of 100 kilobytes. Wow. In each data bucket. So you see the utilization grows on the left side to 100 megabytes, and then it's going to keep going up. Yeah. So yeah, we have 500 megabytes already. So this is incredible. So I just want to put this into perspective for everyone. If storing a gigabyte of data on the Ethereum blockchain today costs you anywhere between sort of $3.5 and $6 or $7 million, depending on the current gas price. Not only that, it will take you an awful long time to upload a gigabyte of data to smart contracts on the Ethereum blockchain. With this, it's happened in really seconds. And not only that, we're going to enable people to maintain that gigabyte of data for just a few dollars rather than millions of dollars. And let me reiterate, this data sits on chain in canisters, which are essentially an evolution of smart contracts. So this is absolutely revolutionary stuff we're looking at here. How's that operation going? Where are we now?
We have 1.1 gigabyte going up.
Okay, so that's really cool. I guess we should think about talking about big search next.
Yeah, sure, absolutely. So one thing we have now is the ability to do full text search. What Big Map now supports is creating an inverted index, and it does so in a similar fashion to what Elasticsearch and Lucene and some other full text search engines do. So it takes your object, you provide an object that you want to make a full text search on, and it breaks it into tokens, stamps it, and creates an inverted index.
This is really important because if somebody wants to create a DApp that is an open internet service, something like a open social network, a social network implemented from autonomous code that's controlled by a tokenized governance system, search is incredibly important for things like that, right? People need to be able to find users and content and topics that interest them. So it's not just enough to have Big Map that can store vast amounts of data. We also need to enable developers to make their data searchable, and this is what that does.
Yes. So let's see. We now don't have any data that is in the full text search index. So if we perform a search for, say, Lord of the Rings, we get no hits, which is expected because the index is empty. The same happens if we do the same thing on the UI, on the web UI. Now, we do have an index of movies, a few movies here, 1,000 or so movies. So now I'm going to add that to the full text search index. It's going to get indexed. And that is done actually pretty quickly.
I mean, this is just so exciting. And actually enabling a blockchain to do search.
Yeah, now we have indexed the movies. Now if we do the search here, it returns some movies here. And for example, I want to take a look at all the movies that Elijah Wood created in the past. So I do search for just name, some other string in this result, and it just lists me all the movies where Elijah Wood is acting. So let me add another full text search index for, say, DFINITY tweets. This is a list of 3,000 or so tweets. So now if we do the search for WebAssembly, for example, it gives us 15 hits. If we do a search on Big Map, we have 2 hits so far. Let's see, when is the airdrop announcement? We see 3 hits.
This is actually a useful search. We should give it to our people in growth and things like that.
When is DFINITY public? So yeah, DFINITY is gonna launch soon, it seems.
That's right. The internet computer's coming. The search index knows it.
How exciting is DFINITY? So a lot of hits here. It seems to be exciting. But actually what I wanted to show is because here I entered the keyword exciting, and the full text search actually returned the results which are excited, right? Which is not
Very
exactly
nice.
the same word. And that is because we do stemming and other techniques to improve search results.
We've shown how we can upload, I think, more than a gigabyte, right, before we stopped it. And of course, the intention is to enable people to create dapps that run on an infinitely scalable blockchain that can store exabytes of data. We've shown how we can enable developers to make that content they collect searchable. This isn't just a revolution for blockchain, but it's a revolution in compute platforms generally. We're going to make creating hyperscale services much, much easier than it's ever been before. And this is all through a completely reimagined form of software. And it's just super, super exciting. We're not going to change people's reference frame in blockchain, but also in the wider community of developers and entrepreneurs. Sasha, thank you so much for all your work on Big Map and Big Search. This is really going to change people's lives.
Thank you very much. It's my pleasure.
A special thanks to Jake Bruckman from CoinFund for giving an overview of the 9 core value propositions of crypto networks. And thank you to Wilson Withiam from Asari for the insightful talk on lessons learned from the DeFi boom and current gas crisis. Liz Yang, thank you for sharing the remarkable projects from our first ever demo day, and congratulations to Sailfish and Get Impact Now, our 2 demo day winners. Enzo Hossaker, great job on demoing the Internet Computer token wallets, as well as to Sasha Tomic for demoing Big Search and Big Map. Last but not least, thank you to Dominic Williams for unveiling the economics and governance behind the Internet Computer.
Next up, we are very excited to present members from our all-star research and development team, which is regarded as one of the best cryptography and engineering teams in the world. We will begin with a discussion around reinventing the computer using advanced cryptography with Jan Kamenisch and Maria Dubovicskaya. Then, Jens Groth will talk on the creation of one public key for the Internet Computer. Afterwards, Manu Drivers will give an overview of the Internet Computer's revolutionary consensus protocols. And lastly, Johan Granström will introduce canisters and how they represent an evolution of smart contracts.
Many people think crypto is really Bitcoin and Ethereum, but actually crypto comes from cryptography, and cryptography, is known since Caesar already, or encryption with Enigma in the Second World War. And already in the 70s, 80s, people realized that cryptography is much more, that you can compute any distributed function jointly by a set of parties without the parties learning the inputs of each other, but just learning the function. So crypto is really much older than just Bitcoin and Ethereum. And everything what we do today has the foundations in the 80s, early 90s. And so that's really now has changed. These things become into practice straight out of research.
And if you think about just 10 years ago, if you introduce yourself as a cryptographer, people are not so excited or interested about this profession. But now, if you introduce yourself as a cryptographer, people are very interested and very excited. And crypto is really on people's mind these days. And it's kind of strange as well to see, because crypto has been around for many ages and thousands of years. But if before it was about like the secrecy of the message, very military or governmental setting, but now crypto is really for people, how to enable decentralization, how to solve actually basically any kind of problem with crypto, and crypto would allow you to do that.
Yeah, 10 years ago, the cryptographer, you were very happy if you could, solve a hard problem and then present it to your peers at the cryptography conference. And now, actually, you can be very happy not only to solve like a hard problem, but also immediately work together with engineers and realize that thing and bring it out to the world and for people to use. So that is very exciting. And I think that's also what excites our team. That's why we were able to get a lot of top-notch cryptographers, researchers, computer scientists to work at DFINITY to together solve these hard problems and get them out and implement into the world. I got it in crypto something like more than 25 years ago when I was looking for a research topic to do my PhD, and I got really fascinated by it. Sort of the things you could do, and sort of remembering when earlier on I sort of wanted to collect a signature for my grandmother on some petition, but then actually the local government in the village would have to certify that actually you're eligible to vote, and then she plainly refused to do that because she didn't want them to learn what kind of political opinion she was having. And then actually realized with cryptography you can actually solve that, right? You can sort of develop a protocol that allows you to, sign anonymously while still guaranteeing that you're actually eligible to vote. So
I first got into computer science and not cryptography. Actually, I was taking ballet classes, and next door there was also a computer programming class. And then once my parents were late to pick me up from ballet class, and I got curious what's going on there. And then later on I was very interested and asked my parents to sign me up for a programming class. And I was also always fascinated and interested about math. And I think cryptography is a really very exciting combination between math and computer science when they come together and actually can solve problems that you wouldn't think that they're solvable. When I think about why I joined DFINITY, yes, of course, it's interesting problems to solve. It's their practical applications and impact on the entire world of computing right now. But also what is not less important is the team. Because the team, not only how skilled and knowledgeable the team is, how brilliant the team is, of course, but also how nice and open people are for collaboration and how easy it is to work with such people. Because without that, you cannot build the most complex thing in this world.
And people join because they like to solve hard problems, get excited about doing that. But also they dived in and started working with engineers to really bring it out and make it happen. And everybody sort of, at least a lot of people have publication history that is huge and impressive, and they all put that on side and just got in and say, okay, now instead of writing papers about it, actually we work with engineers to make it happen and give it out to the world and change the world together.
Some companies have research division is like a luxury, right? They work on like very far-fetched problems on the cutting edge research, but not all of that research is actually brought into the products. In DFINITY, research is not a luxury for us, it's really a necessity, and that's why every team is a composition of researchers and engineers that work together every day. And I think it's very rewarding for researchers to see their ideas to be implemented and applied in the real world, as well as it's very rewarding for engineers to work on such cutting-edge technologies and implement something that was never implemented before that. I think it's very exciting for everyone here at DFINITY.
I'm working on the core of the internet computer, the protocol that drives the internet computer. It's probably the most complex protocol that was ever done, ever developed. So many parts that have to play well together, from non-interactive key generation for the different data centers that together run the protocol, towards consensus, how nodes can upgrade when we change the protocol, when we change the software, how these nodes can upgrade the system without the system slowing down or failing. The internet computer is a decentralized system. It's defined by an internet computer protocol that is run by a number of parties, a number of data centers, and it's run on the open internet, so it's an open protocol. But it also means it has to be very secure because the open internet is a hostile environment. Right? It's like developing technology for Mars, right? Sort of like a very hostile environment, and that's actually very challenging to make that secure.
Indeed, and along the way you need to solve different kinds of very hard problems, actually along all the stack from bottom to the top. If we start even from the bottom with peer-to-peer and how we disseminate artifacts between nodes in this hostile environment, how we do it the most efficient way, and how we define the most appropriate network topology. Then moving up, there is a consensus protocol. How do you make all these nodes running in a hostile environment agree with each other and have the same picture, all of them? How do you make them to actually derive truly random values by just communicating with each other and not trusting, actually only trusting the majority of these nodes?
And there's other protocols that actually are needed as well. So there's like resumptions. If some nodes go down for whatever reason, maybe they're cut off from the internet for a while. So you need to have a protocol that allows them to resume, to sort of get the state from the other nodes. Of course, again, in a way that they don't have to trust any single node, but just trust the majority of them. Or a protocol to upgrade the software. Again, a protocol between all these nodes where they have to sort of agree when to change the version, when to sort of shut down the old version, and then start a new version. So you want to avoid like hard forks here. Just like gracefully run one version of the protocol and then the next version of the protocol again, like very regularly updating the software as the computer goes on and computes its stuff.
Or, for example, how you make different entities or applications running on the system talk to each other in an authentic way. How you make sure that the state that every node on the network has is actually certified, and the node that is behind can catch up on that. And actually, to catch up, you need to really compress the state in a very and authenticate it, and you need to really do it efficiently. And that's how all the cryptographic tools come together to hash and compress the state, but also sign it, but not sign a huge amount of data that needs to be exchanged, but only a small part of it, but enough to make sure that the state is authentic, that the node exchange with each other.
Yeah, and the state potential is huge, right? It could be 20 terabytes that you would have to communicate. And so it's also important that the nodes have a very efficient peer-to-peer network and can sort of get this information from many different places. So that you have to chunk up the whole state so that the nodes can catch up individually, retrieving the information from all the different nodes around them. Not only you have to prove that the protocol is secure, but then you also have to make sure that the implementation is secure, that you do not do any mistakes there as well. And to date, no one has ever proved such a big protocol or composition of a number of cryptographic protocols secure. So that's also like an area where we do really novel work and very, very challenging work. So we need the best cryptographers in the world to address this problem.
Exactly. Both cryptographers and also engineers and systems people that all come together to make sure that the protocol is secure and system that implements it is also secure and cannot be hacked.
Designing and building cryptographic protocols is really hard. It's, a lot of things that you need to consider. And on one hand, it has to be efficient and correct. I'm very excited about this Sodium launch. We get to show a few of the key technical pieces that we have invented here at DFINITY towards our grand vision of the internet computer.
And if there is any team in the world that can pull it off and make it happen, it's the DFINITY team.
I'm Jens Groth, and I'm a principal researcher at DFINITY. Now, the cryptography we develop is not something that the end user sees. The end user just interacts with canisters that are running on the internet computer, and the canisters provide a very easy to use interface to the user, so you can build really advanced systems. If you scratch the surface just a little bit on the internet computer, you will see some digital signatures. And that's because the internet computer certifies and authenticates all its outputs. Digital signatures are the bread and butter of cryptography. It's been with us since the late 70s when the seminal papers of Diffie-Hellman and RSA. But on the internet computer, these canisters, they are hosted on subnets. And these subnets, they are run by a set of nodes across the world. So we need signatures that can be run in a distributed way. And fortunately, there's a solution for that called threshold signatures. The nodes will share a secret signing key. They will each have a small part of the secret signing key. Jointly, they can collaborate to create a signature on behalf of a subnet and authenticate the outputs from the internet computer. At the same time, the set of nodes that are running a subnet, it's going to change over time. Maybe a node crashes, maybe a new data center comes on board and wants to bring in new nodes. That creates a problem, right? Because now I'm going to change the public key every time that we change the set of nodes, create a new sharing. That would lead to a lot of pain in terms of key management. We would have to generate new keys. We would have to distribute those new keys, register them with whoever needs to authenticate information from the internet computer. And it would be really nice if instead we could just have one single permanent and stable public key for the subnet. And that's what I'm going to talk about, how we do that. So there are already protocols that one could use for that, key redistribution protocols that allow you to take a set of nodes having shares of the secret key and being able to bring on board new nodes and giving the power to sign to a new incoming set of signers. However, when you run these protocols in general, they are interactive. So the messages going back and forth between the old signers and the new incoming signers. And that is a little problematic when you're running these distributed asynchronous protocols that we are at DFINITY. So what happens if a message is missing? Is it because it's delayed? Is it because the node has crashed? Is it because the node has been compromised? So what we have developed is a new non-interactive protocol to do key generation and to do redistribution of shares of a secret key. A subnet is always known by one unique public key, and we don't have any key management problems with respect to the public key. Inside the protocol, we use plenty of advanced cryptography, encryption with forward secrecy, non-interactive zero-knowledge proofs, and so forth. So to start with, the internet computer may decide that there's a need for a new subnet, right? And then you have to generate a key for that subnet and shares for the incoming nodes that are supposed to run that subnet. And because it's non-interactive, the internet computer can just generate that, and then there's no interaction with the nodes that are going to run the subnet. At the end of the day, they just need to get a message, a ciphertext that contains the secret share of the signing key, and then they're ready to go. Later on, if we want to change the set of nodes that are running the subnet, then again, we can use our key redistribution protocol. And again, the old signers, it's non-interactive. They just create some messages for the incoming signers, and the incoming signers pick up those messages, and they're ready to go and continue running the subnet. There are lots of other things we can do with this new protocols we have. So you might imagine changing the threshold depending on what is the threat level at the world today. You might also imagine having a backup of the signing key. So you create a secure backup of the signing key such that if a subnet stalls, then you have a way to kind of restart it. So one of the things that we expect perhaps to do the most is that the nodes running a subnet, they reshare the secret key to themselves. At first, that might sound counterintuitive. Why would you redistribute the key to the nodes who already have the secret key and are already able to sign on behalf of a subnet? But it's a neat trick known as proactive security. To explain what proactive security is about, let's think about a subnet that's running for a long time with the same set of nodes. Now, over time, the attacker may accumulate an advantage and try to kind of get more and more information about the secret sharing of this threshold signing key that the subnet has. So it might at some point learn one of the shares from one of the nodes, maybe bribed whoever was running that node. Then maybe later on there's a bug in another node set up, and then the attacker learns that share. And as the attacker accumulates shares over time, it might suddenly exceed the threshold and be able to sign messages on behalf of the subnet. And of course, we do not want that. We want the internet computer to be able to run for years without compromise. So in proactive security, the idea is that you keep on refreshing the secret sharing you have. So first, you have a sharing, then after a while, you refresh it and generate a new sharing, and then you delete the old sharing. So if an attacker compromises a node at this point, it can learn what is the new share, but it cannot learn anymore what is the old share. So you keep on refreshing the sharings you have of the secret key, and you keep on deleting sharings when you're not using them anymore. And in that way, the attacker only has small time windows in which it can accumulate enough shares to start signing. And if it doesn't get all of the shares it needs in a particular time window, then the attacker is out of luck. It's been really great to work with people at DFINITY on the non-interactive distributed key generation protocol. And we are very much looking forward to seeing it in the internet computer.
I'm Manu Drivers, and I work on the consensus team at DFINITY. Today I want to tell you about a few key design decisions that we took when designing our consensus algorithm. But first, I'll briefly explain what that is and why we need that. Security and reliability are key aspects of the internet computer vision. What that means is that I can run my software on the internet computer, and I know that it will be running correctly, meaning the state of my software will only change according to the rules of my software, and it will be running reliably, meaning that my software will not suddenly stop running. And we want these properties to hold even in the world where some computers might get hacked or some parties might be malicious. To do that, we don't just run software on an individual computer. Instead, on the internet computer, it will run on many different machines across the world. And now, it's not just one individual machine that defines the state of my software, but they all do this together. And this way, if some computers individually might be hacked or malicious, they can report a malicious state for my software, but this will not have any effect because the majority should be running my software correctly. For this approach, we need a consensus algorithm. What that means is that the different computers that run my software agree on which inputs to process and what the resulting output is. We have taken some key design decisions that allows us to have a consensus algorithm which supports a high throughput and a low latency. In the last couple of years, we've seen this approach used very successfully by projects like Bitcoin and Ethereum. This really proved to the world how much security we can get via this approach of replication and decentralization. However, they also show how difficult it is to reach consensus between machines across the world. While they have plans to upgrade their mechanisms, as it stands today, they need a huge amount of energy to reach consensus between the replicas. And additionally, the throughput is very limited, meaning these systems can only handle a limited amount of messages per second. And the latency is very high, meaning that if you interact with these systems, you need to wait a long time before you get a result. Imagine that we try to run a ride-sharing app on the internet computer, but the latency is 15 minutes. That would mean every time I request a ride, I would first have to wait 15 additional minutes before my request even makes it to the software. This would be unusable. So to really unlock the power of the internet computer, we need to have a consensus algorithm which has high throughput and low latency. We took a number of design decisions such that we achieved those goals. As a start, we built our consensus algorithm around the random beacon. This is a verifiable random function, which means that the different replicas that run my software can efficiently agree on some random number. This is a secure random number, so it cannot be biased, and we can use that to securely divide some of the tasks in the consensus algorithm between the replicas. This way, not everybody has to perform every task, which of course gives us an efficiency improvement. We've published this already back in 2017, and since then we took a number of additional design decisions to support this high throughput and low latency. For example, we chose to use data centers to provide the computing power for the internet computer. With this approach, we can rely on standardized and very powerful hardware, which allows consensus to run very fast. And at the same time, by using independent and vetted data centers across the world, we can maximize decentralization. A next important question is how we incentivize those data centers to participate. Some projects choose to reward certain specific actions that are part of the consensus protocol. For example, in Bitcoin, you get a financial reward if you produce the next block. This approach has some downsides, namely that the different replicas are competing with each other over these rewards. And this competition is not always beneficial for the overall system. What we choose to do is simply reward data centers that offer computing power to the internet computer, so long as they behave according to the protocol rules. Whenever we see a data center deviating from the protocol, they are removed from the internet computer and will no longer be rewarded. With this approach, we can incentivize behavior that benefits the system as a whole instead of encouraging competition between the replicas. We also had some key decisions at the core of the protocol to allow the high throughput and low latency. One important decision we took is that the consensus algorithm only agrees on the input messages that the internet computer will process. This allows consensus to go very fast because we don't need to do the actual processing of the messages. And at the same time, we use our computational resources wisely. We only process the messages that are agreed upon, and we never waste computational resources on messages that might not end up reaching agreements for processing. To minimize the latency, we look at how we observe agreement. Some consensus protocols take an approach based on network synchrony. What that means is that you need to wait for a certain amount of time, then you hope that you've received all the relevant messages from your fellow replicas, and based on all those messages, you can determine what's agreed upon. For example, if you think of a blockchain, the messages are blocks, and you can observe agreement by looking at the longest blockchain. Such approaches, however, have an inherent trade-off between security on the one hand and low latency on the other hand. If you wait very long to receive all the messages from other replicas, then you're sure you've seen them all after a while, and so you're probably making the right observation that something is finalized, something is agreed upon. However, this long wait is of course detrimental for low latency. On the other hand, if you try to only wait for a short amount of time, you might have missed relevant messages and incorrectly think that something is agreed upon, which harms security. We therefore take a different approach. We add an asynchronous finalization layer to our consensus algorithm. What that means is that the replicas produce concrete evidence when something is actually agreed upon. This means that as soon as a replica sees this message, you know for a fact that this is agreed upon, and you do not need to wait any longer. This allows us to securely go as fast as the network. If a network attack comes in or the network does not behave properly, then this only slows down the consensus algorithm, but does not pose a risk for security. Finally, a lot of projects that use a blockchain to reach consensus are centered around the approach that the blockchain must only be appended to and stored forever. In those projects, we already see that the blockchain reaches sizes of hundreds of gigabytes. We aim to process way more messages than that, which would mean that the blockchain would be even larger. With this approach, it would no longer be feasible to download the entire blockchain and validate each step of the history. For that reason, we added a new mechanism into our consensus protocol, which allows a replica to securely catch up to the latest state of the consensus algorithm without seeing or validating the entire history. This means that we can remove all parts of the blockchain, and a newly joining replica can very quickly catch up and start participating. With this design, we have a consensus algorithm that offers high throughput and low latency. And this forms a solid foundation for an internet computer that's a pleasure to use.
I'm Johan Granström. I'm an engineering director here at DFINITY, and I lead the teams that are responsible for implementing the canister abstraction. We think that software canisters are a key concept that will help us scale a collaborative and open internet. To a first approximation, a software canister is a bundle of code and data that runs on the internet computer. When hearing about software canisters for the first time, people with different backgrounds make different associations. Today, we will talk about 4 different perspectives. First, an Ethereum developer may think about smart contracts. A second, a PhD student may think about actors, as would most people with this type of academic background. Third, a system engineer may think about processes, like in an operating system. This was my first association when I heard about canisters. Finally, number 4, a virtual machines expert may think about WebAssembly modules. All of these associations are correct, but partial. However, together they paint a rather complete picture. So let's go through all 4. A canister is like a smart contract because its execution is governed by a secure protocol, the Internet Computer Protocol, or ICP. Therefore, a canister is tamper-proof. This means that its state can only be modified through messages included in the blockchain, which is governed by the protocol. Also, as the execution of canister code is fully deterministic, a canister's state can be audited in a cryptographically secure way by inspecting the messages in the blockchain. So a canister has all capabilities of a traditional smart contract. In contrast to smart contracts, however, canisters have performance characteristics that makes it possible to use them to build internet-scale software services. In summary, a canister is like a smart contract that scales. Now, let us take a step back and think about canisters from a more abstract point of view. From this perspective, a canister is much like an actor in the sense of Carl Hewitt and others. The actor model is a mathematical model of concurrent computation where, in response to a message, an actor can do 3 things. First, it can modify its local or private state. A second, it can send messages. And a third, it can create more actors. A canister is like an actor in many respects. It has private state that can only be modified by the canister itself. It has a single thread of execution, so it does not need lock-based synchronization. It communicates with other canisters through asynchronous messages, and it can create new canisters. An important difference between traditional actors and canisters is that canisters on the internet computer have a bidirectional message passing. Messages are divided into requests and responses, where requests can be replied to and the internet computer keep tracks of the callback for responders. In actor terminology, each actor has a mailing address that is used to send messages to it. A canister also has a mailing address, which happens to look much like an IPv6 address. DFINITY also develops the Motoko programming language, which is inspired by the actor model. A single canister has only one thread of execution for updates, but the internet computer executes a potentially massive number of canisters in parallel. This is how the internet computer overcomes the performance limitations of some early platforms for smart contracts. In addition, we make a distinction between requests that need to update the state of a canister and queries which cannot modify the state of a canister. While a canister's update throughput is limited by the blockchain and the single thread of execution, a canister can serve hundreds of queries concurrently, achieving a throughput in the order of thousands of queries per second and latency measured in milliseconds. To complete this picture, it has to be added that end users also participate as actor in this model, at least to an extent. This means that browsers and mobile apps can directly perform update and query operations directly on canisters. We now leave the abstract world of actors and look a bit more under the hood of a canister. From this perspective, a canister is much like a process in an operating system like Linux, macOS, or Windows. The operating system keeps track of valid memory ranges for a process, while a canister has a bound on its linear memory enforced by the internet computer. The operating system scheduler wakes up a process when there is work to be done, while the internet computer schedules the execution of canisters. The operating system maintains state on behalf of a process, like open file descriptors and the parent process. Similarly, the internet computer maintains state on behalf of a canister. But instead of things like file descriptors, it keeps track of the canister's balances of tokens and cycles, its outstanding calls, a permission, and much more. Just like a process cannot directly modify its table of file descriptors, a canister cannot directly modify its balances of tokens, for obvious reasons. The operating system provides functionality to processes that allow them to perform special operations, like manipulating files and communicating with peripheral devices. Similarly, the Internet Computer provides APIs to canisters, so they can make payments, call out to other canisters, create and manage canisters, manage permissions, and get the system time. This is a non-trivial function in a distributed system. We also provide access to secure randomness. And as far as I know, this is a unique feature of the Internet Computer. In the future, canisters will also be able to sign Bitcoin and Ethereum contracts through such APIs. Behind the scenes, the biggest difference between a process and a canister is that a canister is replicated over all nodes in a subnetwork. This is the smart contract aspect of a canister. But there are also a few more subtle differences. When a process malfunctions, it crashes. But when a canister malfunctions, caused by a trap in a WebAssembly, it does not crash. Instead, its state is rolled back to what it was before the current message started executing, so the canister can continue execute new messages. Of course, this is of little help if the canister crashes on all messages it receives, but it's a very useful safeguard against accidentally missed cases in the logic of a canister. In fact, a canister cannot terminate in the same way a process can terminate, because there is no exit or abort system call. A canister can only be removed from the Internet Computer by its controller through an administrative command. The controller of a canister is a user or another canister that is allowed to perform administrative commands, such as removing or updating the canister. In fact, a canister controlling another canister is a key ingredient when building autonomous or self-governing services on the Internet Computer. This is an interesting topic, but not my focus for today. So our third point of view is that a canister is like a process running on the Internet Computer's operating system. The last topic that I want to talk about is that a canister is much like a WebAssembly module instance. This is more than just an analogy. This is how canisters are actually implemented on the Internet Computer. Technically, the code part of a canister is a WebAssembly module that imports the system API. That is the functionality provided to the canister by the Internet Computer. Moreover, a canister can export an API of its own that other canisters can call into. According to the WebAssembly specification, a module instance is a dynamic representation of a module complete with its own state and execution stack. So a canister is a WebAssembly module instance, not just a WebAssembly module. This is an important distinction. A canisters use orthogonal or transparent persistence to make it seem like the module instance lives forever. This means that developers don't have to care about databases or a file I/O. To persistently store a variable, you just write it to memory. The operation of persisting the data is completely transparent to the developer, or orthogonal in the sense that the developer does not have to do anything special to persist the data. All writes to a canister linear memory are tracked for two reasons. First, so that failed computations or WebAssembly traps can be rolled back. The second reason is that if a replica in the subnetwork crashes, for example due to a power outage, when it comes back online, it will request modified pages from other replicas so it can resume its operation. This is how the Internet Computer maintains the illusion of providing WebAssembly module instances with indefinite lifetime. The Internet Computer embraces WebAssembly. This gives us several benefits. The most obvious benefit is that canisters can be written in any language that can target WebAssembly, including Motoko. So canisters written in different languages are fully interoperable. WebAssembly is also deterministic, modulo a few special cases that are rather easy to rule out. This makes it a good match with smart contracts. Another benefit is that WebAssembly has a formal semantics. So with a longer time horizon, we expect to see end-to-end formally verified WebAssembly execution environments, providing additional security. Moreover, the Internet Computer will evolve with the WebAssembly specification, adding support for new features as they become mature enough. For example, it is on our roadmap to support multiple modules in a single canister. In summary, a canister is all of these four things. It is a smart contract, it is an actor, it is a process, and it is a WebAssembly module instance. To wrap things up, here are a few key takeaways. Software canisters are the building blocks of the internet computer of the future. Internet-scale services will be implemented by many collaborating canisters. WebAssembly limits the linear memory available to a canister to a couple of gigabytes, at least for now. A service with 1 billion users could require thousands of canisters just to store user data. This is not a problem. The canister abstraction is designed to scale, both vertically by becoming more powerful over time, but mainly through horizontal scaling, or scaling out, using a large number of canisters that collaborate to implement a single service. If you want, you can start developing canisters already today. Just download our SDK, create a canister, and deploy it to the Sodium network. We are working hard, and will continue to work hard, to make it a joyful experience to develop, deploy, and scale applications built using canisters.
And a very special thank you to Jan, Maria, Jens, Manu, and Johan for those very insightful talks.
Next up, we have Andy Bromberg, co-founder and president of CoinList, alongside our very own Michael Hunt, for a very special announcement on the DFINITY Airdrop. Then we'll have a discussion from Vincent Perriard, Gian Boxler, and Mike Schwartz, the co-founders of Origin, a Swiss luxury goods marketplace built on the internet computer. This will be followed by a demo of Open TikTok called CanCan by me. And finally, Olaf Carlson Wee, founder and CEO of Polychain Capital, joins Artia Mogbel for a special announcement, as well as a discussion on the boom of DeFi and the enormous opportunities in the internet computer ecosystem. To close things out, we'll have a live AMA with our very own founder and chief scientist, Dominic Williams, moderated by Michael Hunt.
Hi there, I'm Michael Hunt, Director of Community at DFINITY. In early 2018, the DFINITY Foundation partnered with CoinList for a very special initiative. For the thousands of community members all around the world supporting the internet computer, we wanted to ensure developers and blockchain enthusiasts were given an opportunity to help us reinvent the internet. In the early days, we discussed the best way to allow people all over the world to help govern this new internet. And with the help of CoinList, 2 years ago, DFINITY conducted the largest airdrop ever. Today's Sodium release of the internet computer focuses on economics and governance, as well as represents the final milestone before the public launch of the internet computer, something I know we've all been waiting for. For the tens of thousands of registered DFINITY airdrop recipients, we appreciate your unwavering support and already see many of you building on the internet computer. I'm pleased to be joined by Andy Bromberg, co-founder and president of CoinList, to share an important update on the 2018 DFINITY airdrop. In this segment, we'll tackle some of the most frequently asked questions related to the airdrop, demonstrate the process in which community members will claim their airdrop tokens, as well as give them a sense of what comes next. Welcome to the Sodium launch event, Andy. We're super happy to have you.
Mike, thank you so much for having me, and a big thanks to the whole DFINITY team for inviting me here to speak today. I will say this is a breath of fresh air. I've been to a lot of crypto conferences, too many crypto conferences, and to be at one that is so heavily focused on the developers, the cryptographers, the people that are actually driving this technology forward is really exciting to me. It's a testament to what DFINITY's built in terms of community and technology, and it is a pleasure to be included.
In 2018, we kicked off the airdrop by sending early community members invitations to participate. Users received emails detailing their token allocations in Swiss francs. Community members then completed a registration process and received confirmation emails from CoinList once they had completed that process. Now to Andy to share a little bit more around the current status of the airdrop for participants.
Awesome. Thanks, Mike. So I want to take a couple minutes here to talk about two things. First of all, what is the current status of the airdrop? Where are we at and what's been going on? And then second, I'd like to give a little bit of color about what CoinList has been up to since then. For many of the participants, it may have been a couple years since you visited the site. There's a lot more to offer and that you'll be able to experience when you go back to claim your tokens. But starting with the airdrop. So the DFINITY airdrop closed, the whole process closed on June 8th, 2018. And we've continued to offer support to DFINITY community members that had issues finishing the process. But importantly, at this time, there are no new registrations for the airdrop. Registration closed June 8th, 2018, and we apologize if you missed out, although of course, we'd still love to have you back and participate further in the DFINITY ecosystem through CoinList or otherwise. But I'd like to note that If participants were unable to finalize their registration during the initial process, the CoinList team is just unable to reopen the registration. But briefly, I want to talk about what we've been up to since then at CoinList and what we have to offer you, whether you were an airdrop participant or not, and what you can do on the platform now. Like I said earlier, back in 2017, 2018, we were predominantly set up to run token sales and to allow people to participate in token sales. And that is still the case. We're still running token sales every couple months for some of the best projects in crypto. And there are great opportunities to participate in sales and auctions for these projects as they come up. But over the past couple of years, we've added a lot more features beyond that. First of all, and perhaps the biggest, we've added wallet support. And this is something you will be experiencing as a DFINITY airdrop participant. You should come on and check it out. And if you're an airdrop recipient, when you come to complete your registration, which we'll talk about in a few minutes here, you'll have access to all of these features. You can come in and use them from just a single dashboard. Most of all, we're just really happy to play a role in making the DFINITY airdrop a reality and lead this distribution process. So much of what we want to do is make it easy for you as a user to experience crypto and to get access to these really promising networks.
For the thousands of community members who have been patiently waiting for more information around the DFINITY airdrop, we have great news. Today we'll be giving you a walkthrough of what next steps will look like. It should be noted that what you will see today applies only to the distribution of airdrop tokens associated with the 2018 initiative. For other token distribution related matters, such as launch metrics, exchanges, or Neuron rewards, please be sure to actively follow the Internet Computer Review newsletter to stay up to date. You can do so by visiting DFINITY.org. I'm excited to announce that the DFINITY Foundation and CoinList team have taken steps to drastically simplify the user experience around receiving tokens from the DFINITY airdrop. As Dominic Williams, founder and chief scientist at DFINITY, noted earlier today, the primary token for the Internet Computer is ICP. These tokens, formerly referred to as DFN, will be the tokens that participants will be receiving from the DFINITY airdrop.
Thanks, Mike. Yeah, like Mike just said, we want to make it really easy, really seamless for you. You participated in the airdrop on CoinList. We want you to receive your tokens really easily on CoinList. And that'll happen through this new CoinList Wallets product. There are just a few final steps you need to get set up and collect your tokens. The big one is that you'll need to reconfirm some identity information. That's things like name, date of birth, identification documents, those sorts of materials, perhaps taking a selfie. Once you pass that KYC, you'll have a CoinList wallet. It'll work for DFINITY and other assets. And most importantly, really key to note for those of you who participated in the airdrop, there is no fee for you to go through this process. You'll remember that last time when you participated in the airdrop, there was a fee around the KYC. This time, there is no fee. You'll go through it totally free. We'll help you through the process and we'll take it from there. All right, now let's talk about the process for actually going through and beginning that process of claiming your ICP tokens. It all starts on this page, coinlist.co/DFINITY. Really straightforward. This page has a bunch of information on it, from a video of Dom talking about the project, to information from the foundation, information about the project, information about the milestones and release schedule, FAQs that may answer any questions you might have, a whole bunch of stuff. So we really encourage you to check out this page. But most importantly, if you participated in the airdrop back in 2018, is this blue button, check your airdrop registration status. So that's the button you're going to click in order to begin the process of claiming your tokens. You'll put in the same email account information that you used to participate in the airdrop back then, and that'll begin the process. Depending on the state of your account, there'll be some different steps that you go through, but it'll be really straightforward, and you'll go through that. At the end of that process, once you've finished that whole process of claiming your ICP tokens, you'll be dumped into this wallet view. And you can see right here that my account has 100 ICP tokens available in there, and that's where it'll land. Really straightforward process. Now, of course, once you're in here, there's a whole bunch of other things you can do in your CoinList account, whether that's with the ICP tokens or otherwise. You can see here on the left sidebar a whole bunch of features, buy and sell and pro trading, so you can do trades on the CoinList exchange or CoinList trading interface. You can check out token sales, previous and upcoming token sales on the CoinList platform. We've got a rewards product that you should check out. Really encourage you to click around in here once you've gotten in to your wallet and gotten your ICP tokens here. Again, this starts back on coinlist.co/DFINITY. If you participated in the airdrop, go there, look at the information, click the check your airdrop registration status button, and that'll begin the process of you claiming your ICP tokens. All right, so that's it. All you have to do now is wait and prepare for the inevitable launch of the Internet Computer. We encourage participants of the DFINITY airdrop to begin this process. You can head to that website, coinlist.co/DFINITY, starting today.
Thank you, Andy, for demonstrating next steps and just how simple it will be for all of those early supporters to claim their ICP tokens. To wrap up, let's just chat through some of the most commonly asked questions we get out in the community. So I think the first question, where do I go to check my airdrop registration status?
Yes, you can go and check your status by heading over to coinlist.co/DFINITY. That's the page we showed you earlier. Really straightforward. You can click the button and see the status of your registration. But Mike, one question for you. What are these ICP tokens, Internet Computer Protocol tokens?
For the DFINITY Community Airdrop, DFN tokens will now be allocated as ICP tokens. As it relates to the airdrop overall, there's no difference between DFN tokens and ICP tokens, nor does it affect your allocation amount. So, one more question for you, Andy. Where can I go to confirm my ICP token allocation?
Right, so you can confirm your ICP token allocation by completing that flow on CoinList. Again, coinlist.co/DFINITY, and you'll complete the flow and you'll see a CoinList wallet that has ICP tokens. Now, it's worth noting that those are placeholder ICP tokens until the public launch of the Internet Computer. And so you'll be able to see how many tokens are in there in that kind of placeholder status. And then when public launch happens, those tokens will become transferable.
Got it.
So one for you, Mike, is signing up for a CoinList wallet the only way to receive my DFINITY Community Airdrop allocation?
Yes. So you will need to sign up for a CoinList wallet and pass the associated KYC verification if prompted to be eligible to receive your ICP token allocation. So Andy, I expect community members are going to have a lot of questions along the way and maybe need some support to finish claiming their ICP tokens. Who are they reaching out to for support, and what's the best way to get in touch?
We are here for you. If you registered, participated, you're going through this flow, team@coinlist.co. Team, T-E-A-M, at coinlist.co. We're going to be staffed up, ready. We know there's a lot of you out there that participated in this airdrop, which is really exciting for us. We want to make sure you get the answers you need as quickly as possible. And Mike, what if I've lost my registration details related to the airdrop?
Really good question. So if you do not have access to your registration details related to the DFINITY Community Airdrop, you can reach out to team@coinlist.co. Inquiries will be assessed on a case-by-case basis, and there are no guarantees that we'll be able to process your allocation, but absolutely reach out to team@coinlist.co to try and get help.
So Mike, I know I can go through this process as a user to see how many ICP tokens are in my allocation, but when will those tokens actually be accessible?
So ICP tokens will be unlocked and accessible shortly after the public launch of the Internet Computer.
And then once that public launch happens, what can I do with my ICP tokens?
This is a really good question. So ICP tokens can be utilized in two ways. First, ICP tokens can be utilized to create cycles, also known as fuel. And software hosted on the Internet Computer must be charged up with cycles in order to run. In our efforts to reinvent the Internet, we recognize our opportunity to create value for so many who were left behind in the value creation process of the Internet as we know it today. We definitely hope that you'll stay with us on this journey. As a community, we can be most helpful by supporting the creators and builders who will be taking on the status quo, reinventing global systems, and redesigning the software and products that we interact with daily. You can learn more about how you can stay involved too by signing up for the Internet Computer Review newsletter or by following the DFINITY Foundation on your favorite social channel. Andy, thank you so much for joining us. It's been great having you, and I'm so excited for getting these ICP tokens in the hands of all of our early supporters, and thank you for helping to make it happen.
Yeah, Mike, well, first of all, thank you for being here, having this conversation with me. Also, absolutely from myself and the whole CoinList team, an enormous thanks to the whole DFINITY team for trusting us to run the airdrop and run the distribution and for building some really amazing technology. A big thanks to the DFINITY community for participating, for being on the platform, for dealing with the flows and making sure that they can get their ICP tokens. And I just wanted to say too, Mike, that this has been a really impressive event, the Sodium launch event. I've been to a lot of crypto conferences, I would say probably too many crypto conferences, and to be at one that's so focused on the developers and the technology that's actually being created is really, really exciting. So really happy to be here. Big thanks to you, big thanks to the team, thanks to the community, and we look forward to seeing you all on the platform soon.
I'm Mike Schwartz, co-founder of Origin and longtime supporter of DFINITY and the Internet Computer. Following my work with Tracer from the beginning a number of years ago, whose anchor partner was De Beers, Tracer was devised to implement provenance of diamonds for sustainability and ethically sourced assets through the value chain. And other industry players joined that platform. Since that time, I was always looking for other asset classes to leverage the same kind of benefits. Origin, like Tracer, is concerned with the provenance and authenticity and heritage of real-world physical objects. In the first instance, luxury goods, and in particular watches. Origin allows us to uniquely identify and authenticate luxury watches, and soon other items as well. We're already working with a number of industry leaders. We're leveraging the internet computer, and we've developed some fairly extraordinary technology around the identification of real-world physical objects using image recognition technology and sound files. These items will be embedded in digital twins, which Origin will house and will be deployed on the internet computer. The logic of our systems will be transparent and inspectable, and no single organization will be a majority stakeholder. The infrastructure which supports Origin also permits this kind of ecosystem. And this is also a revolutionary advancement, that we can now create these industry protocols which are open and decentralized, tamper-proof, inspectable, transparent, trustworthy. And the world is in short supply of trust at the moment. So not only we have a future here where entire industries can migrate to this new infrastructure, and now should, but we'll also have an infrastructure that can support consumer applications and consumer experiences that can also be trustworthy from the consumer's standpoint. I think we've all come to learn that the cost of convenience has been very high. Our lack of privacy, what happens with our data, these are costs that we're bearing now and starting to understand the impact of that cost. With these new systems that we can deploy on the internet computer, any consumer can be not only a user but a stakeholder. They can participate in the global economy more effectively. We can have a better distribution of wealth and power, a more effective distribution. People will be able to own their own data and choose when and how and why and who it is unlocked for. They will have the power to do that and nobody else. We expect an increasing number of industry players to plug into the Origin protocol running on the internet computer. And in so doing, we hope to demonstrate to the rest of the world models which they can too leverage to deploy similar solutions on the internet computer also. This is an industry ecosystem play, again, not controlled by any one company stakeholder. The internet computer helps us implement a governance mechanism which enables these industry players to collaborate and cooperate without fear of one of them doing anything untoward. This is also a very new possibility for industry and a very exciting one. I think the world will soon come to learn that the years and the talent that it's taken to build and deploy the internet computer will deliver much more than people expect. With other protocols that have evolved over a shorter space of time, many of them are doing a good job in a particular area, but they're really making up for shortcomings of some of the other protocols that have more broader uptake. I think we're going to find that the internet computer is a largely very holistic solution, holistic infrastructure. It's time to move industry and enterprise-grade infrastructure to the internet computer. It's going to take some time, but enterprises need to start that process now. It's time to do it. There's been a long maturity curve for very good reason, but we now have a level of maturity where these mission critical applications can really look at this infrastructure, really look at these massive cost takeouts, really look at these new business model opportunities, and be confident that there's a level of robustness there that's going to stack up. It's going to take a little bit of time to learn. It's going to take a little bit of time to migrate, a little bit of time to deploy. So it's time to start. It's time to start on that journey now. And I have no doubt that the gains are going to be immense.
My name is Vincent Perriard. I'm a co-founder of Origin, and I'm bringing the expertise of the luxury and the watch industry segment.
My name is Jean Boxler. I'm a co-founder of Origin Project. I'm bringing my expertise in decentralized governance, blockchain, and the internet computer.
In the watch industry and in many other industries, in luxury industries, we all have an issue, is that you have a product and you need something that tells you, yeah, this product is right, is a true product, is an authentic product. And for years and years, decades and decades, we always have a product here on one side and something that says, yeah, this product is right. And usually it's a piece of paper. For 450 years, we're using a piece of paper that tells you, yeah, this watch or this bag or this item is a true one, is a real one, for 450 years.
And we're still using it. With the tech we have today, we're still using it.
2020, we still have a little card, a little piece of paper that tells you, yes, this is right. And you spend like 20,000, 30,000, like 100,000, and you still have something which is disconnected from the product. So the thing is that we realized also in the last month, in fact, when we started all the projects, we realized that there was absolutely nobody in 2020 coming with something where the product itself is the DNA, where the product itself is showing the proof of authentication. And so, yeah, we've seen some people trying to put a little chip, a digital, like an electronic chip into the watch. Of course, you cannot. You cannot have a mechanical movement with electronic inside. It doesn't work, it's not allowed, and it brings some like issues. You're adding some issues instead of like solving some issues.
Yeah.
So really the idea was to find something which is based on the picture. It's really to like take a picture, go in so much detail that suddenly the product is obviously always different from the other one.
Like a biometry, we have that with human faces, and actually it's a very simple idea to have the same application of biometry, but with a watch. Exactly. And the watch is like the fingerprint. Every watch is different. There is tiny, mini difference, and an AI is able to recognize those differences.
On the watchmaking side, one of the dreams was to be able to create a digital twin, okay, where it's not something which is external to the watch, but it's the watch itself.
It's really a digital twin.
Digital twin.
Yeah.
And then we are a few months or a few years later, and as you said, we are in Tokyo, in Ginza, we're having a drink, and you want to know if the watch that you see on your wrist, if it's a real one. You take your smartphone, you make a picture, I will call it like you Shazam the watch. And in 1 second, it will tell you when was the birth of the watch, if it's an authentic watch, and it will give you the whole story about who owned the watch, and if it was stolen, or if it was lost, or whatsoever. I remember we had those meetings in Los Angeles with Mike and the team, and we were like brainstorming, I'm talking like a month ago, where the idea was, how can we solve an issue with the technology? And it was really interesting because they all came with some ideas like we can bring a chip, we can put a QR code, we can add something on the product. And I was always saying no. no, no, no. Like every language I was saying no. Say no, we need to find something where you're not touching the product. Can we use the photography to, like go inside the structure of the watch?
And I think that a brand like Audemars Piguet is even recording the audio of the movement, right?
Every watch, like a heartbeat, like a human being, you have your heartbeats. Every watch has a signature, a sound signature. The movement is creating a sound, a specific sound with a specific curve when you read that on the screen. And if you record it at the birth of the watch and you listen up the same watch 3 years, 10 years later, you can see or you can recognize if this watch is the watch that you created like in 2012, for instance. So there is a sound and an image recognition, which is really, the idea is really to use both elements into Origin to make sure that we are, like 100% right. And this watch is the watch we have minted like 10 years or 5 years ago.
What the Internet Computer is allowing us is to have a platform which is a standard that the watch industry can use, because counterfeit is a problem for everyone, right? So finally, you're solving a problem, and there is no one owning actually a company. Everyone is using a platform, and then all the data and the information of those digital twin are embedded through a token, for example, and are using a blockchain. And then this is also that new era that bring DFINITY, a new economy actually, and a new model, a new governance model.
Origin is, like bringing a new technology where for the first time in the history, we are, enabling it to have the product itself to be the proof of authentication. So the product itself can be seen, can be checked, and not a piece of paper outside of that. For the first time, that's the technology. The second point is definitely the technology behind it, so the internet computer. The fact that we can scale it, and the fact that we can monetize it, so we can also leave it for the governance.
New type of governance?
New type of governance, that's very important. And the third thing is maybe, and here with Origin, the fact that it's not just tech guys, but it's a combination between tech guys and people from the luxury industry that really understand each other suddenly, because usually in that world, you have the great tech guys and you have the luxury guys on their side. And here with Origin, we are just like giving the balance between luxury and tech, and we're bringing like a new thing in the industry to solve a problem and to bring to turn a cost into a revenue.
My name is David Fan, and I'm software engineer at the Origin project. I'd now like to give you a short demo of what we've built at Origin using the DFINITY Canister SDK. The high-level architecture of this demo will outline the minting of a tamper-proof digital twin of a real-world luxury watch by outlining the functionality of 3 canisters. The first one is the Origin canisters. It stores most of the digital twins or certificates. The second one is the Origin asset canisters. This stores and serves the front-end Vue.js files. And we have the big map canisters. This set of canister allow us to store large files. So we already deployed the canisters on the internet computer. And as you can see, we have 2 browsers. On the left, we have the one from the watch manufacturer, and on the right, we have one for the watch manufacturer storefront boutique. So here, we are the manufacturer, Audemars Piguet Le Brassus, and we want to register. So we will just register on the Origin protocol. AP Le Brassus. We register. On the right, we are the boutique, and we register on the platform. So let's say we are AP Beverly Hills. Now, as a manufacturer, having just manufactured a new luxury watch, I want to create its tamper-proof digital twin on the origin protocol. So I will just go on the registration page and I will just input the relevant watch data. So I will select the branded model, select the reference number, select the assembly watch, location, watchmaker name, and I will input his unique ID. At this point, as a watch manufacturer, I will upload a high-resolution image of the front dial of the watch. And in the same time, I will upload a unique sound signature file of the tick of the watch. These files are quite large, and we will see later how we leverage DFINITY's implementation of BigMap, which allow us to upload large files to the internet computer. Now, again, as a watch manufacturer, I'm double checking the information I've entered previously. The protocol checks the validity of the picture and the sound files. As we can see, the image validation model detected the watch and its bounding box. It all looks good to be minted. All set, we've minted the digital twin on the origin protocol. Let's look at the certificate details. Here we can see the certificate and all the details we've entered. We can see that we can transfer the certificate. We also have the watch timeline, which describes all the different events that could happen to this watch during its lifetime. There is the ownership history, and more importantly, we have access to the manufacturer data. This manufacturer data is used to ensure the unique identity of the watch on origin, and will be used later on by the artificial intelligence engine that we are building at origin, in order to identify and authenticate a watch at any point in its lifetime using a smartphone. So, as a manufacturer, I now want to allocate this watch to a boutique, the Audemars Piguet Beverly Hills boutique. For that, I will digitally transfer the certificate using the origin platform. In the browser on the right, you can currently see that there is no watch in the Beverly Hills boutique's inventory. So I will trigger the certificate transfer by selecting the recipient of the certificate, AP Beverly Hills, and I will set a memo for this transfer. So the transfer has been successful. We can see that the watch timeline has been updated in line with the transfer, in addition to the ownership history. So now, let's check the AP Beverly Hills inventory. Now, as a boutique, I can see that I have received and own the unique digital twin of this watch, and I am able to see all of the manufacturing data. So now, let's talk about some technical challenges that we've solved with the help of the DFINITY engineering team. If you watch the minting process carefully, you will have seen that we are handling large files uploads to the internet computer. We upload high-resolution picture of the watch and sound signature files whose size can be up to hundreds of megabytes. If you follow the ICP Tungsten event, you will have seen the TikTok clone built on the internet computers that leverage the BigMap technique to store and retrieve large files. At Origin, we've worked closely with the DFINITY engineering team in order to integrate that into our protocol architecture. The integration was pretty simple. Now we will look at a piece of code relating to the JavaScript integration into the BigMap canisters. Basically, there is a 4 GB memory limit per canisters due to the WebAssembly design. In order to bypass this limit, we'll break our files into multiple chunks spread across multiple BigMaps data canisters. So you can see here, we just have set the chunk size to 500 kilobytes. The function upload files does it all. It will take the file, fetch the metadata, split the files into multiple chunks, and upload each chunk into different BigMap data canisters. You can see that here we are turning the file into an array buffer, and we are just chunking the file in different chunks and uploading them to BigMap. And we are creating these manifest files that we are putting on BigMap, and that's it. For the file retrieval, there's a snippet of the code that we use, the function getFile. It is basically the reverse operation of the upload. First step is to retrieve the manifest file and parse it. And for each chunk in this manifest file, we will retrieve the chunks from BigMap. Finally, we will just concatenate these chunks. So this is a quick overview of the BigMap interaction with JavaScript. There are some other points that still need to be implemented on our side, such as access control of the data and BigMap data rebalancing. So this was the demo of minting a watch on the Origin protocol, and I hope you enjoyed it. Big thank you to the DFINITY engineering team for helping us shipping this demo.
Back in March, when we first started working on CanCan, an open version of TikTok, little did we know just what would unfold over the summer. TikTok's popularity was exploding as the world hunkered down during COVID-19, and we wanted to show that a decentralized, scalable version of a video sharing app was possible on the internet computer. What we didn't know was just how relevant our work and the concept of open internet services would become amidst political battles, turmoil, and public scrutiny that TikTok and big tech are currently facing. On September 1st, we ran a survey from our DFINITY Foundation Twitter account and asked all of you who should win the bid to buy TikTok. And 61% of the participants said that they would prefer an open version of TikTok like CanCan. This begs to question, if users are asking for it, why hasn't someone built it yet? One reason could be that many believe that building something like TikTok, let alone a decentralized version of it, is a hefty technical challenge. And I hope that my demo today will show you that it's not only possible, but it can be easy. Since you last saw CanCan at our Tungsten launch event, we've made significant improvements. First, we've improved the performance of BigMap, the scalability solution we created in both Motoko and Rust, to shard and balance data across canisters. Here in CanCan, we are using the Rust implementation, and it stores videos as binary blobs. We're working on even more improvements such as canister forking, which will make CanCan lightning fast. Next, we've added Big Search to CanCan. Earlier today, you saw a demo of Big Search written in Rust, which has been optimized for performance. We also wrote Big Search in Motoko, which you can see here. The most incredible thing about the Motoko implementation of Big Search is how simple it is, nearly 50 lines of code. The Motoko implementation of Big Search leverages several open source projects, such as Motoko Sequence, Motoko CRUD, and the Motoko base library, and we use the Vessel Package Manager and its DFX integration to include them in the larger CanCan project. CanCan demonstrates that open internet services can be created from multiple smaller services, which are themselves created from individual open source libraries, and in multiple languages, in this case, BigMap in Rust and Big Search in Motoko. Thanks to the interface description language Candid, every service running on the internet computer is interoperable with every other. That means you can import external services as easily as the libraries. With CanCan, these services can interoperate with a common JavaScript program in a common way via Candid and JavaScript Rust libraries that understand this common data language. I also want to mention that our team has been testing our own developer experience as we updated CanCan through several releases of the SDK and Tungsten network upgrades. Let's take a look at CanCan running in action. So what you see here is a live instance of CanCan running on the Tungsten network. So let's go ahead and log in. So what you see here is a pre-seeded video feed, and as we scroll through the feed, what's happening is the chunks of these videos are being retrieved using Bigmap. So what we'll do next is go ahead and upload our own video, and let's go ahead and select a video of my adorable senior dog, Beans. So as the video of Beans uploads, what's happening is it's being broken up into chunks and sharded and rebalanced across the network. Great, so it looks like the video of Beans has been uploaded, so let's check out our profile. And there it is. So we can see the video of Beans in my profile. And let's get a look into Big Search in action. So here in the Discover tab, we can see several of the pre-seeded videos, all of which have their own captions and hashtags associated with them. CanCan uses Big Search to store chunks of user-provided text. Each chunk is a text file that are each associated with metadata, such as the CanCan video IDs. It demonstrates simple algorithms that index the text and then search across these data structures. So what we can do is let's go ahead and search for one of the hashtags I attributed to my video of Beans, hashtag dog. And you can see that some of the pre-seeded videos that we had of dogs show up using Big Search, and also the new video that we just uploaded of Beans. I also use the hashtag cute, and there it is. If we click it, we're able to access that video again. So let's go ahead and try to upload another video. This time a video of Beans eating a cannoli, just to show you again how Big Search works. So now we're uploading a separate video of Beans, this time with a different caption, so that we can try out Big Search one more time. So now that we have both videos of Beans uploaded, we can see both are now in my feed. So let's give another try to Big Search and search for cannoli. And there's our video of Beans. Throwing it a like. We are really excited about the future possibilities of CanCan. We hope that Big Search shows you that as users and developers, we have alternatives to centralized search and black box algorithms, and that it can all be done in less than 50 lines of Motoko code. This combination of Big Search and Bigmap unlocks powerful user-first functionality, such as breaking up captions and hashtags in one place and the video in another. Because CanCan is going to be open source, anyone can spin up their own instance of CanCan on the internet computer, allowing us to create bespoke networks for our coworkers, our friends, and our family, and to selectively share those instances of CanCan into other instances. In many ways, CanCan represents our vision to restore the power of the internet back to the people, and we hope to see you on there.
So we're coming up on the DFINITY mainnet launch in Q4 this year. And with that, we're seeing a big influx of developers that are looking to build new types of applications that are unprecedented and not before possible on the DFINITY Internet Computer. And we're excited to announce that we're going to be investing in a lot of these entrepreneurs through the Beacon Fund, which is a fund managed by Polychain with $14.5 million with support from both the DFINITY Foundation as well as Andreessen Horowitz.
Yeah, and we're happy to be partnering with you on that.
And I think that the core thing is recognizing that because we're in such a new area with blockchains, these are actually new inventions. And when you think about big historical inventions, like say electricity, it's not like a faster candle, right? Yeah. It obviously led to all sorts of applications that nobody could have really conceived of at the moment of the invention. We're really excited not just to invest in things that are a little faster or a little cheaper, but really new types of applications that are sort of unprecedented. And what I mean by that is that DFINITY represents a massive technical breakthrough. New types of applications are going to be made possible that simply were not possible on any previous system. I think to me this is really similar to the step function change that Ethereum represented relative to Bitcoin. A lot of people, when Ethereum launched, thought about it as potentially threatening to Bitcoin, or that would this be a better Bitcoin or something like that. But that's really thinking in hindsight, right? It's thinking through the lens of the existing reality, which was all Bitcoin. What was actually exciting about Ethereum we know today is all the new types of applications that were uniquely made possible by Ethereum. These are things like multiple assets settling on one chain, things like stablecoins, and of course everything with DeFi, decentralized crowdfunding, trading, lending, all those sorts of things. What I'm excited about with DFINITY is not the fact that it might be able to implement existing applications faster and cheaper. It's rather what types of new, unprecedented applications are going to be uniquely enabled by the internet computer. And so when we're talking to entrepreneurs and investing out of the Beacon Fund, what we're very excited to do is find people who have a vision for new types of applications and platforms that are uniquely possible with the internet computer and are sort of unprecedented in that before we had major web marketplaces and web platforms, there wasn't like an analog version. So when Facebook was launched, when YouTube was launched, when Uber was launched, it's not like they were a faster or cheaper version of some previous application. They were really a completely new way of organizing people. And so in this case, I think that the launch of the internet computer is going to lead to substantive new ways to organize humans and capital. And I think that new applications are going to emerge that were not possible with sort of legacy technology that we have today. I think that the internet computer will lead to new types of applications that are very hard to think of.
Yeah.
I think an interesting anecdote is I once saw a video of Marc Andreessen. It was in 1995. He was in front of the audience talking about Netscape and talking about the internet. And he got a question from the audience, which was, what are some interesting websites on the internet? And he struggled so hard to find an answer. And he ended up saying that Tower Records put up a website, which is, this is the thing, is that the internet obviously changed everyone's lives and led to all these unprecedented applications. But even as the person who is the creator of one of the foundational elements of the modern internet, Marc Andreessen, it's very hard to reason about and predict all the various ways this open platform will be used. And so with the Beacon Fund, we're very excited to partner with those entrepreneurs early. One of the ways that I think about this is entrepreneurs are often extremely rewarded for taking an early bet in an ecosystem that ends up blowing up. So you can think about this in the context of developers that were very early to Ethereum. Many of the very early Ethereum applications got sort of a lead, they got the most liquidity, the most capital interest, and have been able to sustain a moat as the Ethereum ecosystem and platform has grown. But this goes way beyond blockchains. If you look even at just some of the early apps in the iOS App Store, by taking a bet on the iPhone and the App Store, many of those developers who built even just utility apps, like the flashlight app or something like that, were able to carve out a market share early, and because the underlying platform and ecosystem grew, they sort of had outsized macro tailwinds behind their business or behind their application. And so to me, we're looking for entrepreneurs to invest in that are willing to take this sort of bet on the internet computer architecture. And as we see an ecosystem of application developers emerge around the internet computer, there's going to be that macro tailwind effect, and disproportionate rewards will go to those who took risk early. You've seen this empirically on Ethereum. There are smart contracts that have become, managers of over $1 billion that were built by individual developers, like one person. So I think we are seeing kind of $1 billion of value be created by smaller and smaller and smaller teams. And this is the next logical abstraction where it won't just be one person, it'll be like a teenager, or I don't know what the next step is. Once you're one person generating $1 billion of value, I don't know what the next step is. But I think that we're going to see many, many of these applications that reach immense scale that are the work of a very, very small team.
I would love to hear about some of the successful first movers you've seen in the space and why you're excited about first movers building on the internet computer.
Well, I think a lot of the successful first movers, for example, in Ethereum, took advantage of the new features in Ethereum to try to build something that wasn't possible before. So on Bitcoin, some of the really early applications were things like Satoshi Dice, which allowed you to sort of gamble double or nothing based on the next hash of the newest block and things like that. I think that Ethereum didn't try to build like the successful entrepreneurs didn't try to build a cheaper, faster Satoshi Dice or something. They really started to build applications that were uniquely enabled by Ethereum. I think some of the early applications there were tokens that bootstrapped on top of the Ethereum security mechanism without having to generate that security themselves, and decentralized crowdfunding to initially distribute the token as well as raise a capital pool that could be managed by those token holders. But I do think that the people who were the most successful were building for a long-term future. A lot of projects on Ethereum kind of fizzled out because they ran with the hype a little bit. But people who really were focused from the early days on delivering a meaningful product, I think have seen substantial success. So these are groups like, for example, MakerDAO. The MakerDAO project was one of the first applications on Ethereum. Today, it's one of the largest smart contracts by capital managed in the entire Ethereum ecosystem. People like to say you have to be smarter or you can be first. And I think being first is often easier. Just being the first team to build a certain type of application in a new ecosystem or using a new piece of technology can be one of the very positive macro tailwinds for building a successful business. This is very similar to early application developers for the iOS, iPhone, and that got into the Apple App Store, even with relatively simple apps, have seen great success simply because they were first and sort of planted the flag there. So I think as an entrepreneur, taking a risk on a new protocol or platform can be a really legitimate strategy to building a successful business.
And would love to touch on any of the investments that you've made so far, and maybe just one example and why.
So the first investment that we made out of the Beacon Fund in 2018 was Compound Finance. And so we had a lot of conviction around Robert Leshner as the founder of the Compound system. And he had an incredible vision for how to start off as sort of a centralized business that would deploy a smart contract system with a very narrow but extremely scalable model, which was just a borrow and lending marketplace on Ethereum.
Simple.
Very simple, but very well executed. And then over time, actually decentralize ownership such that this would become sort of public infrastructure managed by the community. And I think that every step of the way, the execution has been stellar. And we couldn't be happier to have him be sort of the first person that we invested in out of the Beacon Fund.
Would love to hear a little bit about your process. So I'm an entrepreneur. I've read through the documentation. I understand the benefits of the internet computer, and I'm able to grok what it means to build on an open, non-proprietary platform. And I get in touch with Beacon. What can I expect?
We're in general going to just want to jam with you on the ideas you have for what you're building and how it works. We have a very, very technical research team that's capable of definitely going toe-to-toe, with any entrepreneur building something, no matter how complex it may be. I think in general, we're going to be looking for people that have a lot of grit and a lot of vision and are ready to build something very big. And again, kind of natively understand what it means to build in this kind of Web3 open context. As far as the process, in general, it's going to be a conversation with someone from our research team. Then it's going to be a full team pitch to our entire investment team. And then we're going to follow up with any additional questions we might have, and then we're going to decide to invest or not. We like to move very quickly with our investment process. And once we do make an investment, we like to partner very closely and make sure that any entrepreneur we're working with has identified like the one bottleneck that may dramatically limit their ability to succeed, and also the one catalyst that is going to 10x the size of what they're building. And that they relentlessly focus on breaking down the bottleneck and executing that catalyst. So to me, it's it's not that the relationship ends with an investment. That's actually really where it begins, and we hopefully can work with entrepreneurs for many years as they continue to expand what they're building in this whole new ecosystem.
Got it. In terms of entrepreneurs that are early, may have a prototype in market, haven't raised any money yet, what do you think they can expect to raise?
In general, as an entrepreneur, you want to go as far as you can with the resources you have, because you will get better value for your equity.
Yeah.
And this is true after you raise a fundraising round. You want to take that capital as far as you can to build what you have as big as you can before you raise new capital. So in general, that applies before you've raised any venture capital as well. The more progress you can make before you go out and raise venture capital, the better valuation you're going to get.
Yeah.
But I think in general, these types of businesses that are built on top of open platforms are not very capital intensive. I think the biggest costs are sort of security and infrastructure engineers that are going to actually write all of the application logic, as well as security audits to make sure that the canister you're deploying is going to work as intended. But net, what that means is a very lightweight software business. There's not a lot of heavy assets or big capital investment that needs to be made the way that if you're starting a big hardware company or you want to manufacture cars or something, there's going to be a lot of capital needed. So in general, I would recommend staying lean, and I think a reasonable seed round when you're sort of pre-product and you're just an idea and a founding team is usually about $500,000, maybe as much as $1 or $1.5 million. But I think raising more than that is usually not necessary, and you're probably just selling more of the business than you really should.
Yeah.
Because you're going to determine whether you have product market fit with that $1 million.
Yeah.
And if you can't, then there's an execution problem, or you're building something that there really isn't a market for.
Yeah.
So the goal of a seed round to me is to ship something and figure out if there's product market fit. If there is product market fit, it's time to put fuel on the fire and raise growth capital, right? And a kind of Series A type growth round. But you just want to raise enough that you can find out whether your product has product market fit or not.
Yeah.
Okay, so Artia, how should entrepreneurs who want to get in touch with Beacon, how should they do it?
In addition to getting in touch directly with the Polychain team or with the DFINITY team, there's also a way for entrepreneurs to apply on dfinity.org. So there is an application process. There is a page with some information on the Beacon Fund. So the application will ask for basics like just founding team information, whether you have a deck, but most importantly, whether you have a prototype in market, or even better, a minimum viable product in market that you're able to get some feedback from customers or users. So the two ways to apply are get in touch with our teams or check out the application on dfinity.org.
Yeah, I think entrepreneurs should just get in touch any way they can with anyone really at DFINITY or Polychain. And we'll make sure that it gets seen by the right person. I mean, we're going to be very actively looking for entrepreneurs over the next 12, 24 months, especially who are looking to build kind of novel applications in this area. What's very exciting when you have a new open protocol system that entrepreneurs are building on is you have this sort of grassroots collective imagination about what the future could be. And it's sort of like the early internet or like early Bitcoin, early Ethereum, whereby you have a lot of dreamers kind of working through the idea maze and trying to figure out what really is possible and where there really will be substantial pull from the market for these new types of applications that are sort of unprecedented and uniquely made possible by the characteristics of this new platform or protocol. And so to me, everything that's happening with DFINITY and the ecosystem around it is just really exciting to be a part of. And for me, kind of helping catalyze entrepreneurs' dreams and make it a reality is what gets me so excited about everything we're doing at Polychain and with the Beacon Fund.
At this stage, we're pretty much feature complete, but there's an awful lot of optimization and security work that needs to be done before you launch the public network. So, for example, we've got some very talented security people, and one of them found that you can use WebAssembly to run side channel attacks. So, we're digging deep and we're looking for just about every perverse attack that's possible, and it's going to take a couple of months at least before we're happy to launch the network.
That's a great answer, Dom, and something that I do see asked quite often in the community is to what extent the DFINITY Foundation will be working with people out in the community or maybe independent auditors to really make sure the network is secure before it goes live. Are you able to speak to that a little bit more?
Yeah, sure. So, the internet computer is a very complex project, and it involves a lot of, if you like, high science. We're developing new cryptography and new protocols. Pretty much everything's new. And that means the investment you need to make before you really understand what's going on is that much greater. So, first of all, it's very important that we ourselves hire full-time security experts that can, really go to town on this and invest the time necessary to make it safe. However, of course, we also care enormously about community pen testing, but that's going to happen at a later stage near launch.
Got it. So one thing that people in the chat may not know, maybe some of them, that the DFINITY Foundation was founded back in 2016. And back in 2016, a lot of projects out there could really only dream of just creating a faster Ethereum, so to speak. But here at DFINITY, we've clearly taken a different path, and we've set ourselves on this really amazing vision. And I would just love to hear you speak to why choose to build the internet computer versus kind of focusing on that mission of just building a faster Ethereum?
Well, the vision was always to create a sort of web speed, infinitely scalable blockchain that could host the world's software and data. And we've stayed true to that. That's why the project is called DFINITY. DFINITY is just a shortening of decentralized infinity. So, that's what we set out to do originally, and we haven't deviated from that plan. I think generally, the internet computer represents the third great blockchain innovation. The first was Bitcoin, the second was Ethereum, the third is the internet computer. All of them are very different things. If you look at the way, blockchain has evolved historically, and, when after Bitcoin came out and everyone was obsessed with it, and that was the latest and greatest, if you like, or the first and greatest. We had all of these altcoins, you had Litecoin, Feathercoin, hundreds of them, in fact. Where are they now? Most of them have disappeared, right? They were just copycats. And, then we had Ethereum, and that's proven hugely successful and was completely revolutionary in its own way. And, it's no wonder then that we get all of these copycats. Everyone's out there raising money on the proposition they're going to build a faster Ethereum and do Ethereum 2.0 before Ethereum and so on. We don't want to be, we're not a copycat project. Everything in the internet computer is developed from scratch, is completely novel, it introduces new ideas. And, frankly, it takes us to a place that most people still cannot even imagine. It takes us to a place where we have a blockchain that, should be capable of hosting the world's software and data. And that means that for the first time, people are going to be able to build websites, enterprise systems, internet services on a public platform. We've taken, the idea of blockchain, the Bitcoin introduced, where a public network created this virtual platform. In the case of Bitcoin, of course, it's just a very simple ledger. In the case of the internet computer, that ledger has transformed into a sort of platform for software that executes in that single tamper-proof trust environment. So this is transformative. People are going to be able to build websites, enterprise systems, internet services on a public network rather than on closed proprietary systems like Amazon Web Services. And this is something very different to a cloud too. This is something completely new. People can create autonomous software. They can process, value and data, value and identity as data, and just do things that you just simply cannot do today. And of course, the internet computer is going to mean that things that we've struggled to do in the past on blockchains like Ethereum suddenly become very easy. So that's why, we took on the challenge. It was always our vision to provide the world with this functionality and not just produce a faster blockchain, but actually provide a public network that can act as an alternative to legacy IT. And, the internet computer reinvents software, reimagines software, and we introduce things like orthogonal persistence and so on. So, we're really trying to reinvent many different things, not just blockchain. We want to replace legacy IT.
Got it. And Dom, so knowing that, we've been working on the Internet Computer project for about 4 years, and we're just now coming up on public launch in the next few months, it's very likely that it'll take us many more years to fully realize the vision for the Internet Computer. So to individuals out there watching right now who may be thinking about joining the DFINITY Foundation or joining the DFINITY team to work on this, what would you say to them to kind of get them across the line and remind them why they should be submitting those applications and thinking about working with us on these problems?
Well, first of all, the DFINITY Foundation is working on some of the most exciting cutting-edge computer science around anywhere. We're working on programming languages, virtual machines, distributed computing protocols, advanced novel cryptography. You name it, it's here at the Internet Computer Project. So, if you're an advanced software engineer or researcher in a relevant area, this is an absolutely, if your passion is for computer science, this is a great place to work. If you're a community member thinking of building something on top of the Internet Computer, I put it this way. First of all, I don't think the next generation of kids is going to be building on Amazon Web Services. Once they find out you can just write code to the internet and it's tamper-proof and unstoppable, it requires far less code to create a scalable, hyperscale internet service such as Instagram. They're going to just want to write code and push it to the internet. If you're an entrepreneur, it's 100 times easier to surf a wave than it is to paddle out. Building on the Internet Computer is surfing a wave. I think things will develop much faster than people expect. I mean, look, here at the DFINITY Foundation, we're in this for the long term. We're going to be improving the Internet computers, working on alongside other foundations being created now, by the way, working on improving the Internet computers, protocols and technological implementations. But I think we're going to start seeing exciting internet services appearing pretty early on, because this uncorks the blockchain genie. Now people won't be limited by gas costs and scalability and speed. They can serve user experiences directly from the blockchain, from cyberspace into browsers, and this is a game changer. So, for example, we've already got a bunch of amazing projects being built on the Internet Computer. Everything from very serious games through to pan-industry systems. This is going to be a big thing. So don't wait around. This is your chance. Surf the wave.
Speaking of the games, we're going to come back to that in just a moment with a quick question. But one thing I wanted to chat about, often out in public, people notice us relay ourselves to organizations like DARPA and CERN. And can you just share a little bit more on why we tend to make that connection out in public?
Well, we see ourselves as a very serious research and development organization. And, the team has a lot of very brilliant researchers and engineers. And we're trying to extend the internet. We're also trying to redefine the internet, from just being this public network that connects everyone to being a public compute platform that hosts the world's systems and data. So, we're definitely part of that tradition. I think what's so exciting is that, the internet was created because of the impetus of the Cold War. A lot of money was poured into its development because, the world wanted a communications network that could withstand a nuclear strike, and when the Cold War passed, the funding sort of dried up, and the internet since then really has only seen incremental developments, and which are pursued by researchers at universities and so on. There isn't really the funding there to take it on the next step. I think one of the fantastic things that blockchain sort of achieved was providing a way to fund the development of public networks. And of course, the internet's a public network. So, we're like, okay, let's extend the internet with the internet computer and fundamentally transform what the internet's about. And I think in the future, in the same way that people won't think about all those private networks that their data flows across when they're connecting to each other over the internet, they won't either think about all of those individual node machines running in independent data centers around the world that are creating this internet computer platform, which of course is an entirely virtual thing, for the developer and user. They don't have to know anything about the individual data centers and nodes behind it any more than you need to know about the private subnetworks in the internet when you transfer data over it.
I wanted to take a moment and switch gears a bit to start talking a little bit more about governance of the internet computer. So as you know, today we shared a little bit more about what next steps look like for people who have been participating in the airdrop. And aside from utilizing their ICP tokens in the future to participate in governance, and of course utilize that ICP to create cycles to run their software on the internet computer, we wanted to see if there was a little bit more that you could share about exactly how neurons work and why it's so important that we have people out in the community creating neurons and participating in the governance of the internet computer.
Yeah, well, simply put, the more ICP tokens that are locked in neurons in the network nervous system, the more secure it is. Obviously, a fear would be that some party would purchase a sufficient quantity of ICP and lock them in neurons that it could control the network nervous system or influence its decisions on proposals in a way that's detrimental to the network. Now, it's very unlikely any individual would want to do that, of course, because they'd be investing a huge amount of money in these ICP tokens only to lock them inside the network nervous system and devalue them. So in practice, this is very unlikely. But all the same, I mean, the more community members that acquire ICP tokens and lock them in neurons and configure those neurons to vote either by manually as a result of them voting or automatically as a result of other neurons that they've chosen voting, the better, the more secure the network will be.
Let's chat a little bit more about the network nervous system. So are you able to share a little bit more about the functionality and the properties of the network nervous system that you expect people to be interacting with at launch? And then perhaps could you share a little bit more about what you imagine the network nervous system to look like in maybe just a few years?
So that's a really good question. First of all, the network nervous system is fundamental to the functioning of the network. Okay, so the internet computer scales out by creating new subnetworks. And new subnetworks are obviously created by drawing nodes from independent data centers around the world. That process is actually driven by the network nervous system. So the network nervous system is fundamental to the functioning of the network. So that's just one kind of network management function, but there are lots of other functions. It's involved in the economics of the network, potentially even other areas. When you create a neuron, you can configure it to vote automatically on some topics and not vote automatically on other topics. So, for example, most people will configure their neuron to follow various foundations or the neurons of various foundations and leaders in the space with respect to network management, because they won't want to be, looking at all of these proposals that come through all the time. I mean, they could come through very, very regularly indeed. But they might decide they want to vote manually on for example, a protocol upgrade that's going to introduce a major change to the way the network works. So I think the network nervous system, because it is open and algorithmic, is going to create, it's going to be very entertaining to watch it evolve and how its role, I think it's going to change over the years. I mean, in the end, the network nervous system has the ability and will all the time push updates to the ICP protocol and the software that's running on the nodes. And so in a sense, it has absolute control of the network.
Got it. So Dom, on the same topic of governance, I want to pull a quick question from the community. So how does the internet computer ensure that it won't be privatized when it's being built by a private foundation? And does the DFINITY Foundation plan to remove itself as a moderator at some point?
Well, first of all, the DFINITY Foundation is a not-for-profit Swiss foundation. And a not-for-profit Swiss foundation cannot have members. That means there's no stock. The foundation has a purpose that's described in something called a notarial deed, and that specifies what it can do. So the purpose of the DFINITY Foundation is to develop the ICP protocol, to develop technical implementations of the ICP protocol, such as the software running on those nodes in data centers, and to promote the usage and adoption of the internet computer network itself. And that's all it can do. So DFINITY Stifting, the DFINITY Foundation, is really a terminator. It cannot be acquired because there are no members. All it can do is pursue its purpose in the notarial deed like a kind of terminator. It can't even pivot. If the world decides that the internet computer is a terrible idea, makes no difference. The DFINITY Foundation will just keep on marching on, trying to make ICP and the implementations of ICP better and encouraging people to use the internet computer network. And there are some other organizations which I can't announce quite yet, but the announcements are coming soon, which will also play similar roles within the internet computer ecosystem. So people need to have absolutely no fear that the internet computer, either the organizations involved in the ecosystem are going to be privatized or the actual network itself can be privatized. In the end, you can't privatize a protocol, right? I mean, you can't privatize the Bitcoin protocol and you can't privatize ICP. And as the years go forward, there'll be more and more independent data centers, running these specialized hardware nodes that connect together over ICP to create the internet computer. And there's absolutely no chance that anyone's would be able to or would want to privatize it, because the value of the internet computer. Largely, it's not just about the technical innovations and the way you can create things like scalable, tamper-proof code. It's also about the fact that the internet computer is a public platform. We don't want to build AOL, we want to build the internet.
So Dom, today we saw a bunch of really great presentations from DFINITY team members all over the world. But one presentation that I've noticed has caught the eye of many community members was today's presentation on Big Map and Big Search. And I would just love to hear from you, what is it that excites you the most about Big Map and Big Search, and especially getting those tools into the hands of developers that are looking to utilize the network?
Well, I mean, first of all, of course, the reason we're called DFINITY is we're pursuing decentralized infinity in a sense. We're trying to enable the world to build all its software and host all its data on a blockchain, a public blockchain. And, I think Big Map and Big Search demonstrate the sort of progressive realization of that vision. Another part of the vision actually relates to my own background. I created systems that had to scale in relation to a game I created, which had some millions of users. And I'm very interested in distributed computing and scaling and so on. And also, I've been programming for many decades now. I won't say how many. And I've always felt there was something, wrong with the legacy IT stack and didn't like various aspects of it and felt there must be a better way. And, I want people to be able to create Instagram or WhatsApp or Facebook, as an open internet service, which is controlled by a tokenized governance system, but also in far less lines of code. And I think this is a very key point that a lot of people miss. It's not just about creating a blockchain that can process an infinite number of transactions. It's about enabling developers to create systems that scale. And we want to do that far better than the legacy IT stack. And I think with the Canister framework, the way that our code can reside within this infinite universe of software, we're achieving that. But there are always going to be some complexities with creating a hyperscale internet service, and we don't want developers to have to deal with that. So part of the magic of the internet computer is that you can create interact with an object that interacts with other canisters, right? Which are just kind of like these things called actors, which are the kind of objects of the internet computer. And ultimately, every actor has its own memory, which can have up to 4 gig of memory. So you can get the illusion almost that you have infinite memory and create something like a hash map that stores exabytes of data. And that's what we're going to give people essentially with Big Map and Big Search. We're going to give people a very simple kind of collection object that allows them to store vast amounts of data. And actually, I didn't think we were going to get a Big Search ready for Sodium, but Sasha made huge progress with it. And so, that's also very important for developers creating internet services. Like, it's all very well having creating open Facebook or something like that, but you have to be able to search for content, right? I mean, actually, we need to retrofit this to Linked Up, which we demonstrated in Bronze, because in that case you didn't have a scalable search system. And of course, if you want to have a professional profile network, potentially you'll have very many millions of professional profiles.
So Dom, one more question on scalability, and this includes cycles and Ethereum as well to some extent. So, as we've seen the rising gas prices on Ethereum and it acting as a barrier to scalability for some developers that are building projects on that network, can you share a little bit more about what gives you confidence that this won't be a problem on the internet computer, especially as it relates to some of the more computationally intensive projects that people might be wanting to build, such as video gaming and others?
Well, remember that Ethereum is a finite resource. Okay, so today's blockchains don't scale out. That means you have to have a way of mediating which transactions get into blocks, and that's why we have things like fee markets on Bitcoin and Ethereum. And if lots and lots of people are wanting to submit transactions on Ethereum, the fee market decides whose transactions get in by raising the price. And I think recently I heard that it's like $75 to submit a transaction to Augur. So the internet computer is a very different kind of blockchain. It scales out horizontally, and it's not a finite resource. And for that reason, cycles have a fixed cost. They're a kind of stable coin. So, cycles being the equivalent of gas on Ethereum, and you can buy them at a fixed cost for all time. And as time goes on, the number of cycles consumed by computation will fall because, of course, the underlying hardware gets faster. So the difference is enormous. If the internet computer runs out of capacity, it doesn't raise the price of cycles. It just adds more nodes. And to begin with, of course, we need to make sure the network is sufficiently large that we don't get caught out by variance. And that's why we already have hundreds of nodes running. Initially, there's always going to have to be quite a lot of headroom. But eventually, of course, the law of large numbers, the same thing that makes the internet more efficient every year, will allow that headroom to be brought down. But, that's how the internet computer works. Cycles are extremely cheap. When the internet computer is getting short of capacity, more nodes are added to the network rather than the price of cycles going up. And to be absolutely clear, the cost differences are absolutely staggering and enormous. It will cost you $4 to $6 million to store a gigabyte of data on Ethereum, and it will take you a very long time to get that gigabyte of data onto the chain. As we've seen from the Big Mac demo earlier on, it doesn't take very long to get a gigabyte onto the internet computer. And I can't tell you what the final cost is going to be in cycles right now, but with a fiduciary subnetwork, the cost per gigabyte of the hardware itself is about $10. But we've got other kinds of subnets which will be specialized for storing data, which will bring that down. So it'll just be a few dollars. It's a bit more than a traditional cloud, but at the end of the day, the biggest expense you face as an entrepreneur or developer is actually developer time. And that comes from complexity. And the internet computer enormously simplifies the task of developing internet services.
So Dom, there's a community question here that I absolutely want to ask, and it's relating to sustainability. And the question is, data centers, of course, require a lot of electricity. Is there any plan for the DFINITY Foundation to partner with data centers which are sustainably run, or perhaps is there anything else that you might want to share on this as it relates to the way we are working with independent data centers?
Well, remember, firstly, the DFINITY Foundation doesn't control the internet computer network. The internet computer network is controlled by the onboard in-protocol algorithmic governance system, the network nervous system. So a data center that wants to join the network and be able to add nodes or submit nodes that can be inducted must first get a data center ID. So they actually apply to the post-launch, they have to apply to the network nervous system. The DFINITY Foundation won't control the internet computer network. It'll obviously have an influence within the ecosystem, just like the Ethereum Foundation does, but we won't control it. But I think there's two parts to this question. The first is, look, I think everyone, governments need to tax electricity, and that will drive data centers to seek greater efficiencies. And of course, we hope that happens. But aside from that, I think it's very important to recognize that legacy IT actually uses a huge amount of electricity. Now, we look at legacy IT and we see replication everywhere. We see replication of data between the index and data file of databases. We see master-slave. We see memcached. We see content distribution networks replicating data all over the world, and so on. So when you look at legacy IT and you look at the lack of consolidation and the silos, and it's horribly inefficient. We believe by moving the world's websites, enterprise systems, and internet services onto the internet computer, even though it as any blockchain does, it uses replication for the purposes of security and so on, it can reduce the electricity consumption of all of that stuff that's currently built on legacy IT. And of course, when you're looking at traditional blockchain like Bitcoin or Ethereum, I mean, that actually works through these kind of electricity burning competitions. Like proof of work is an electricity burning competition. The more electricity you burn, the more hashes you perform, and proportionally, the number of blocks you produce reflects your share of the electricity that's being burnt, right? And I mean, there's different, people will give you different accounts of how much those two networks consume currently, but it's anywhere between, 0.5% and 1.5% of global electricity production. We hope the internet computer will demonstrate to the world how a blockchain can be more secure than those existing networks, which suffer from centralization in mining pools and things like that, be more secure and more reliable than traditional blockchain networks, and yet consume a tiny, tiny fraction of the electricity per unit of compute performed. So we hope the internet computer will play a fundamental role in reducing the electricity consumption of IT and helping the fight against climate change.
Got it. So Dom, we have just a few moments left, and I want to take a couple of community questions that relate to both strategy and, the big tech narrative. So the first question I want to ask is really around, what is DFINITY's strategy for competing with incumbents like AWS, Microsoft Azure, Google Cloud? Why should someone really consider building on something like the internet computer, or maybe even attempting to port their project over to the internet computer versus these more established organizations?
Yeah, so first of all, internet computer versus Amazon Web Services isn't sort of works as a comparison, but it doesn't really. They're very different things. The internet computer enables you to do things that you cannot do on Amazon Web Services. Imagine trying to do Bitcoin, create a digital currency on Amazon Web Services. Well, first you get a contract with Amazon Web Services, then you create a single, some kind of cluster of machines on Amazon Web Services that host the ledger. I mean, no one would be interested in it, right? People are interested in blockchain because, first of all, you're building on a public network. Secondly, it's tamper-proof. Thirdly, it's unstoppable, and so on and so forth. And including, of course, that you can, process, value and identity as data. So these things are revolutionary. Look, I mean, I think we're going to see a huge number of people that want to create open internet services. Everything from games, games, open Salesforce, open Facebook, you name it. We're going to see a vast range of open internet services on the internet computer. These will have enormous advantages compared to traditional internet services. They'll be built from autonomous software that is controlled by tokenized governance systems that run as part of the fabric of the internet itself. They're going to be able to guarantee, they're going to be able to trustlessly share functionality and data so that you get what's called service composability, and entrepreneurs can build on each other's systems without having to trust each other. And of course, users are going to get a much better deal with respect to things like transparency. But if you're an entrepreneur outside of Silicon Valley, or even in Silicon Valley, and you want to create a new social network, well, good luck going to a VC and trying to raise money for building a traditional social network that's going to compete with Facebook. But an open internet service is a completely different kind of thing to a traditional, internet service run by monopolistic big tech. And it has a number of killer features that you just can't get from those kind of services. So, all of a sudden it becomes viable to do something like that, to reinvent the internet ecosystem. So that creates greenfield opportunities for entrepreneurs. Also, the tokenization of services is going to provide ways for developers around the world to raise money, hopefully in much more responsible ways than we saw with ICOs, but to raise money to develop the future internet ecosystem. So, rather than just the 0.5% of the world's developers in Silicon Valley having a shot at developing important new internet services, pretty much anyone in the world, if they can get a talented enough team together and build a fantastic prototype, is going to be able to convince people to possibly fund what they're trying to do. So it's going to distribute opportunity around the world. And in turn, that's going to unlock an absolute treasure trove of talent. It's just a myth to assume that, all of the talent's concentrated here in Silicon Valley. Talent is distributed around the world. It's just that, even if you're located in somewhere like London, it's very, very difficult to raise money compared to Silicon Valley. So this has the potential to sort of uncork the genie of worldwide talent. And that's another big reason that entrepreneurs should think about building open internet services rather than banging their head against a brick wall trying to beat big tech at its own game.
So Dom, I have just a few more questions for you, and looks like we're pretty quickly running out of time. So maybe we tackle these ones, quite quickly. So this is actually a really interesting question from the community, and it's, what's not possible to build on the internet computer?
Well, that's also a really good question. Well, I mean, I should say first of all that over time there'll be different generations of subnetworks that use different kinds of hardware. So, what's not possible now may become possible later. And a good example of that is AI. You can certainly run AI and Bayesian classifiers and so on the internet computer. But if you want to create neural nets, you may have a disadvantage. Well, you will have a disadvantage against, for example, Google's TensorFlow cloud. So, that's an example of something that wouldn't be competitive to build right now. Obviously, over time, we will address those kind of needs, but that's not what you'd want to be building right now. You can certainly build, various MMO games on the internet computer. If you wanted to build some kind of, point of view shooter like, Call of Duty, that would be harder. Albeit there are probably ways of doing it with query calls and things like that, which I haven't thought of. But there are lots and lots of things that you can build right now. I mean, you can stream video, you can create scalable internet services, you can create, software as a service type systems like Salesforce. I mean, honestly, there's so many things that are there to be created by entrepreneurs. Inside, actually, we didn't have time to do it. I wanted to create something called Rainforest, which was like a decentralized Amazon as a sample app for Sodium, but just didn't have time.
Yeah.
Everything. There's a whole world of opportunity.
So Dom, my last question for you. Should we find success here at the DFINITY Foundation and the world with the internet computer, what's to stop, a larger player out there in big tech from, spinning up their own internet computer and sharing that with the world?
Well, firstly, the idea of, big tech running the internet computer or building it itself is kind of antithetical to its purpose. The world didn't want AOL, CompuServe, or Microsoft's internet information superhighway. They wanted the internet. They wanted, a global public network. And, that's also true of the internet computer. People don't want Amazon Web Services. They want the internet to be the compute platform. And, all of those independent data centers that will participate in the network will probably have second thoughts if it were actually somehow controlled by big tech. So I don't think we have to worry about that one.
Dominic, thank you so much for joining me here today and agreeing to take some of these questions from the community. For everyone else that's watching, as you know, during the Tungsten event, we opened up the network to third-party developers for the very first time. Now, with the closing of the Sodium launch event, we are going to be opening up that network to everyone. So the people who are interested in developing projects and applications on top of the internet computer can now begin sharing those projects with the world, bringing on users, getting people testing their applications, and really seeing how this thing works. We'll also be introducing wallet canisters and cycles. So do please go to the DFINITY website to learn a little bit more about that. And you can do so by visiting dfinity.org/sodium. Thank you again all for joining us today. If there's really one thing to take away from this, it's that we really want you to get out there and start building. And for those of you who aren't necessarily developers or you don't know developers, now is a really good time to start taking a look at the projects that people are building. Things like Sailfish, Get Impact Now, and we'll be sharing so many others with you from our end here on the community side. So please do take a look at some of the things that people are building. I think you guys will be pleasantly surprised what people can build with the internet computer. Thank you, Dominic. Thank you, everyone.
Thanks, Mike. Thanks, everyone.